Hello guys, good morning. Good morning everyone. So, okay team, just a few things. Some of the member who have enrolled for the program, however, they have not yet joined our WhatsApp group. Okay, so they don't have these details, even though the email was shared. Maybe some of the members missed it out. So today's session is going to be even live streamed on public platform. Okay, so on YouTube, we will do today's session as live itself. And from tomorrow, it will be all happening internally so that if last moment rush should not happen for the people who have enrolled. Okay, for that reason. So I am starting it up into a YouTube mode. Meanwhile, everyone, please request you to log in from your laptops. Log in from your laptops and be fully focused. The discussions that we will be having, this will completely change your thought process, your personality, your technical abilities, your job hunting approach, and it will help you to get the job quickly and make a great career. So all of these discussions are pretty career changing and life changing discussions. Okay. So I want you to allow yourself to think and evolve. Okay, fine. I think we are running it live as well. Let me share the link internally. Then I'll put the video on, share my screen. Meanwhile, everyone, please log in from your laptops. And wherever we are taking some summaries, where we say, hey, can you summarize these few things? Please involve there. Please do the summary by yourself. It will be all very much required. Okay. So let's go. I will share this link in our internal group and we will start with today's topic. So here we go. Good morning, everyone. Nice to see you. This is the YouTube recording live link for today. Today's session is publicly open. From tomorrow, we do internally. Okay, here we sent and here we go. Okay. One more tip, guys. Try to be in a place where you are not disturbed for the next 3 hours. So yes, it is a long time, but try to be in a place where you will not be disturbed so that you can fully focus on this one. Okay, so this is something really important. So once you start preparing in this manner, okay, where your focus grows, automatically a lot of benefits will come to you. Okay. So keep your phones away, like don't do any social media and other kind of stuff. Let's get started with today's topic, guys. I'm sharing my screen. Let's start with today's topic. Okay, here is the screen share. Okay, team, please quickly confirm if the screen is visible. Can we start with the topic? Audio, screen, everything is good. Can we start? Okay. Nice, multiple members. So guys, welcome first of all to the week number 2. It's going to be really loaded with lot of valuable discussions, and I want you to grow your logical thinking. Don't behave like students, everything should be just kept in front of you. No, working professionals are like thinking people. Your logic has to grow. So when you're doing something, questions will come. You have to think more on that questions. You need to learn how to use internet to solve your problem. I will tell you something. As soon as I got my job into the IT industry, the first task which was assigned to me, so I came up with whatever solutions I can and then went to my technical lead. You know what he did? This was my first like exposure, first task in the IT company. The first thing he did was, he asked me, okay, what is your task? I said, this is my task. He just went to Google immediately. He did not even look at my solutions. He just went to Google and pasted some kind of a query there in the search bar. 4 or 5 links came where blogs were already written on the technical concepts which I was building. He launched 3 or 4 of the links, read something for like maybe 1 minute, And he gave me 3 links and said, okay, whatever your solutions are there, try to evaluate with these 3 links, and after that come up with final solution, then we will discuss. So the approach here is, you have to learn to use internet to solve all your problems, technical problems, exploring and everything. You need to reduce the dependency with other people. Okay, maybe in your college time, you might be going to your friends or your faculties, okay, help me, what to do this, what to do that. You don't need anyone. Okay, you just need the internet and the power of AI, and your mind has to grow to use these things properly. So become self-sufficient, become more capable to deal with your things, and you will find, okay, life really becomes easy after that. So this is practical stuff. So guys, few basic instructions before we start with our week number 2. So yes, as we know, the full plan is already clear. Monday to Friday, daily 3 hours will be there. Saturday, Sunday, no sessions. So you are all aware of those things. Few important things, please make sure you are either doing it daily watch session. This can be live or recorded. So based upon the past people observation, I'm telling you, just imagine if you don't watch today's session completely, what will happen? Tomorrow, next 3 hours. Day after tomorrow, another 3 hours. Within 3 days, 9 to 10 hours of topics will be there. And guys, dekho, aim is not to just finish a recording. Aim is to practically do things. So you have to code, you have to think, and for that additional time will be required. So just imagine if you have only 9 or 10 hours of pending work, then how will you get time to do it practically? So this is what happened with several people of the previous batch. Those who were not able to catch up with the day-to-day topic, even though we completed in 2 months, but still for them to complete, it still took 4 months or even more. So the recording will be there, so people can watch it later. But important thing is, if you can do it in less time, why not give your 100% during this 2 month itself and get maximum output? So don't slow your progress down. Okay, so you will be expected to daily do 3 hours of live or recording, whatever, and then do practically, which will need another 3 hours from you. So total of 6 hours to 7 hours you have to give to this project daily. Total 6 to 7 hours required. Some people, what they do is, I'll tell you multiple approaches. You can figure out which one will work best for you. And I'll tell you the pros and cons of both of the approach. One approach is you do everything live, the way right now we are doing. And then during the day, spend additional 3 hours to complete all the tasks. Okay, you will get strong understanding with this approach, because it will be something like this. Firstly, you do everything live. After that, when the tasks are provided, you need to watch the same YouTube recording, okay, maybe in a faster mode, double X mode, and skipping the topics and going to the places where you're supposed to do the task. So if you do it via this approach, same topic you will complete 2 times, plus tasks will also happen. You will get more deeper understanding about everything. So this is the approach number 1. So you can apply, watch the recording. Then after that, when the tasks you are performing, you need to parallelly watch the recording 1 more time and then do the task. And wherever you are stuck, you have to use internet and AI, solve your problem. Whenever errors are coming, brainstorm with internet, and then you will be able to solve it. Logically, you will grow every single day. So this is the best way of getting knowledge, because you're double repeating it, you're exploring, you're doing it. The another one, if you say 6 to 7 is a long hours, then how some people do it is, they, okay, catch right now, instead of joining it on Google Meet, they join it on YouTube itself. So every single day, we will stream it on YouTube in an unlisted manner. So it will not be publicly open, but it will be available to the people who have the link. So in the group, we will be sharing the link. So what they do is, while the live session is going on, parallelly, they will be doing the practical tasks as well. So they will just maybe pause it on YouTube. So even though live streaming is happening on YouTube, they will pause it. There itself, they can perform the technical actions while the live session is going in this manner. Okay. While watching live itself, perform action, perform tasks. Everything that we do here, you have to do the same thing. So while watching live itself, with this manner, maybe around 4 to 5 hours, you can finish the topic. The drawback with this approach is, compared to this approach, here you will get less understanding. Simply being, here you are thinking about the topic only one time. So it's not about completing the topic. It's about strongly understanding it, and repeating the topic 2 times will give you strong understanding. So the people who follow this approach, yes, more work will be required for you, but better understanding will come out, compared to if somebody is saying, okay, one shot me itself, I want to do both. Yes, you can finish it, but comparatively, your knowledge will be less. And the problem will come to the people who don't complete day-to-day topic. The one who are not finishing topic daily, for them, pile up will happen. Okay, so please. And I think what happens is, as the session goes further, maybe even after 4 weeks, so not many people are able to be in catch up with day-to-day topic also. 50% strength really cuts down, and they all are watching from recordings and they are all lagging behind. So please don't let that happen to you. Okay? Your aim should be to belong in top 20% of this group who has joined for the program. Everybody should compete for that. Why? Because success is only in the top 20%. You go for an interview drive, 1,000 people are coming, only 200 are good, remaining 800 not good. So everywhere, so where the selection is going to happen, where the shortlisting will happen, only top 200 people. In this group also, who will be the people who will get the job quickly? Top 20% people will get that quickly. Remaining, yes, they will keep working, but if you work slow, results will come slow into your life. So one primary mission you do, whichever career line you pick, whatever course you do, you have to set up a goal. I need to be in the best top 20%. Accordingly, work for it, because result is only in the top. Rest of the world will stay struggling. That's how life operates. Hikes. If there is a 10-member team, everyone does not get a good hike. Promotions, 10-member team, one person might get promoted. So only the top 20% is where results happen. And you have to belong here wherever you are. Okay? So guys, are we clear with this? So decide what approach works for you, become strongly knowledgeable, and belong into the top 20%. Okay, this is one. Another thing what you do is daily mark attendance. So let's say yesterday's attendance, if you mark today, fine, it will be counted. But then today's attendance, you cannot mark today. Every day, only one attendance. Every day, only one attendance. Even if you mark 5 attendance today, it will be counted as only one. It will be summarized based upon your email. So please make sure daily you are marking one attendance. You can mark, let's say, week 1 attendance also today, if you are watching a week 1 session today. Okay, and that's what, every day one attendance required, and all this attendance will be tracked throughout the end. And by the end, those who are having demo criteria is going to be there. Okay, if your attendance is 70% and above, you need to submit 5 total demos. And then if your attendance is less than 70% all throughout the 2 months, then you have to submit 7 demos. And this is the criteria for trainee completion letter. Trainee completion letter. So please be aware of this. Keep this thing in mind. Don't wait for last moment, because what happens is, if you're not making regular demos, so in the end, doing 5 becomes a lot of problem. Currently also, the previous batch people, they are now also submitting the demos, and they will continue to do that for the next 1-2 months also. Why you are slowing down your own growth? Please don't do that. Keep this in mind. We are just in the week 2 now. We have 2 months in front of us. Make sure you are achieving these demos. What to give in the demo, how to give in the demo, we will discuss that separately during this week itself. And you need to target by end of week 2, at least first demo is submitted. And guys, there is a magic in demo. If you give the demo, your knowledge will multiply like anything, compared to just watching the sessions and doing the task. Once you give the demo, your interview explaining skills will grow, and then crystal clear clarity will come in your thought process. So you will realize that interviews will become easy for you. Conceptually better understanding will happen. Technical capability will improve as well. and you yourself will realize, just keep giving demos. It's very important to evolve you. Okay, okay, fine. Chalo, all these things are done. Let's start with the today's topic. Guys, are we clear? Are we clear with this initial base things? Daily do the sessions. Don't let the work pile up. Make demos, make attendance, and belong into the top 20%. That's how results will come. Okay? And another thing, one thing you have to always, I want to just clarify basic things. Dekho, getting the job is always hard. It's not only for your time. When I was starting in my career, 2010, 2011, there also job market was very bad. Okay, 2008 real estate crashed, and then the entire global economy also suffered. Lot of job seekers were there. It was very hard to get the job, but yes, we got it at that time. For you also, you might say AI challenge, this challenge. Okay, fine. Still people are getting. 3-4 years ago, COVID and all, there was challenge. Still people got. So the conclusion you have to understand, getting job is never easy. It is always hard. It has been hard before you were even born from the planet, and it will continue to be like this till the end. Okay. Somebody said this very important point. Success or opportunity is always available in front of you, but it is wrapped in problems. Remember this statement. You can get the job, but it is all filled with problems. Success and opportunity is always there, but it is always filled with problems. You need to solve those problems, become capable, and then results happen. Okay? So always remember this thing. And so don't feel low about yourself ki nahi mil raha and all. Every market is hard. You have to grow so that you can solve the market problems. Okay? So please remember these things. Let's start with today's topic. We're going to start with microservices today. Okay. So as part of the week 2, a lot of things will be done. Point is, at a high level, we will start with microservices and technical discussions today. These topics will be required almost in every meetings, every design discussions, and all technical solutions that you will be doing in project development, whether it is here in the 2 months or whether you are doing it in your companies. These today's concepts will be required. These are foundational concepts of building systems. So from technical perspective, we are going to discuss that very important topic. Okay, fine. Next, tomorrow we are going to do the Stripe setup and understand Stripe integration, APIs, and work with that. So again, project related, very important topic tomorrow. After that, in this week number 2 itself, we are going to get into deep dive into Spring Boot, okay, Spring and Spring Boot from coding perspective. In the week 1, we coded first API, but we don't know anything about Spring and Spring Boot. We need to start with the core concepts, containers, dependencies, objects, initializations, injections, and how the foundational things of Spring and Spring Boot work, because then we can better build the systems and debug the systems. So we will be spending time in understanding that. And if the time permits, we will even be closing on the REST API standards, the concepts of resources, how to best design APIs. So we will be finishing all that. That is going to be part of the week number 2. And from week 3 onwards, the sprint 1 will start, where we will be doing functional development, and that will continue day by day, every single day till the end of the program. Okay? So please be aware, this is the plan. Okay, fine. Next, like we said, again I am repeating, till this week 2, the refund option and exit option is going to be available. So in the session material, wherever we have our session material link, all form link is available, right? So during the week, sometime we will be setting up the refund and exit form. So you check during this week how it is applicable, and are you able to match up with the pace of whatever we are doing. And due to any reason, if you want to discontinue, so in this form, we will be updating the refund form during this week, maybe Wednesday or Thursday sometime, we will be updating it here itself. I will inform it in the WhatsApp group also. Okay, so you can opt that, and by the end of this week, Saturday, Sunday, we will initiate the refund via Razor Pay itself. Okay? So just be aware if due to whatever reasons. But ultimate thing is, if you don't learn all these things right now, basically you are going to slow down your own progress. So that is not a good approach as well. So think about it, analyze things properly, and then continue forward. Okay, chalo. The base topics are clear. Let's start with the technical topic for today. Everyone, full attention. We are starting with microservices. Okay, so there is a nice history about microservice. So it's a very beautiful concept, commonly used. Many of the projects in the current times is using microservices. So by the end of today's session, I will even be sharing this document with you where you can find some bullet points about microservice-based architecture. There is a very nice technical definition of what is a microservice. But right now, we will not try to understand this definition, because once we understand what is microservice, the journey of microservice, how it evolves, what are the technical concepts, then this definition will become obviously clear to you. So don't try to learn things from definition perspective, try to understand the concepts. And it is something like this is microservice. A microservice based project. This simple diagram looks like a microservice based project. Don't code everything in one big project. Rather, code it into small pieces. And these pieces can communicate with each other. Whenever somebody from outside want to talk to your system, it all has to happen from one single entry point. All your microservice should not be exposed to the rest of the world. Hurry, that simple concept is of microservice. So what is microservice? Don't code entire project as one big project code. Rather, break it into small systems. These systems can communicate with each other. Whenever an external guy is trying to talk to your system, they all will do via one single entry point. And this kind of an architecture is a microservice based architecture. So what do we say? What do we say? Don't code entire project in one go, rather than break it into smaller pieces. And these pieces can communicate with each other. Okay, next, when external system want to talk to your code, they will do via central entry level software. Okay, nobody can directly talk to your services, always entry will be there. Okay, all these things are good, but you need to understand there is a background to microservice where this guy, Martin Fowler and James Lewis, these two are the architects who long time ago has laid down some principles which say what is microservice. Okay, so microservice is not something new. It is a pretty old concept, like 2013, 2014, at that time it started emerging, like 10 years old, more than 10 years old now. So here is the background about it. What happened is, earlier, whenever you build a project, okay, whenever you build a project, some technical architecture needs to be followed for project development. Agile is a process of software development. Like that, there is a technical guideline also which should be applied in the project when you are building the project. For a very long time in the past, this approach was there of monolith. Code everything together, one big bulky application, and then run that, and it does all the functionality. So several problems came with monolith. Then people said, oh, monolith is not working, projects are suffering, we need a better approach. That better approach came, further improvement in the market, SOA, which is service-oriented architecture. So service-oriented architecture solved some of the problems of monolith in a very effective manner. And then people said, yes, SOA is the future, service-oriented architecture is the future, every project should have this kind of approach. But there were some severe problems even with service-oriented architecture approach also. We will discuss some of them, what exactly it is. And then people realized, yo, SOA is also not working. And many people started saying, oh, I think then we should go back to monolith world itself. And the world needed a better solution. So what people did is, some of the smart architects of the world and the technology geniuses, they studied, okay, how we can overcome this problem of SOAs better. And as a result of that, they took principles of SOA and further improved it. And that is where emerged microservice-based architecture. Okay. So microservice-based architecture. So it is further evolution on top of SOA. Some good things of SOA is considered further, bad things are removed, and then further enhancements also happen. And then microservice came into picture. And then what started happening? Okay, it was basically the IT is a global career, right? Software development is a global industry. Just think about it for a moment. It's a big globe, so many technical companies, so many projects, so many developers, so many experts. Who is that one person who can define some definitions for the entire world? Right? Some common standard which the entire world should follow technically. Who is going to define that? So generally, it's pretty hard thing, right? Some standard of technicality, which is global, it is not something easy to accomplish. And then what happened? Some people started doing this microservice-based definition, and they all said, okay, we are building microservice system and we are very happy. So people started having some self-discussions, okay, what might be a microservice, and then they started building the application. In long time earlier, 2013 we are talking about. And then what started happening? Every project, they are saying, oh, we are doing microservice, we are doing microservice. But then after discussing with people, nobody had actual clarity, okay, what exactly is microservice? Because different people were following different approaches, and they are all saying we are doing microservices. Confusion came to the world. So many projects, everybody saying we are microservice, and they are all following different things. So now that kind of confusion was really disturbing in the market. And that is where these two technical guys came in forward, Martin Fowler and James Lewis. What these people started realizing that, okay, people are saying that microservice is powerful, and it was actually powerful, but there is no clarity, okay, what exactly it means to build a microservice-based system. And then they realized, if this clarity does not come to the world, the way SOA got confused and people wrongly started implementing SOA, and that caused problem, they started thinking, these two guys, that same thing might happen to microservice also. Then what they started doing, they started discussing with people. They are themselves great technical guys, but they started discussing with other technical experts into the field who were claiming that they are doing microservice-based applications. And then they started interviewing people, discussing with them, how are you building? What is this? What is that? Why like this? Why like that? They themselves are technical guys who are building the solutions. And then what they did in 2014 itself, long time earlier, they came up with the core 9 principles, which defines a microservice-based application. After discussing with a lot of people, they said, these are some common attributes or common principles that majority of these projects are following. And if you want to build a microservice-based application, then you should also follow majority of these principles. Please understand, there are different principles. Maybe you might not apply all 900%. Even if you do maybe the top 5, you can still call yourself microservice. So don't say that, okay, all these 9 principles have to be implemented. And over the period of past 10 years, few more modifications or enhancements happened, but the core principles remain the same. If you strongly practice and understand these, you will be able to build great microservice-based systems. Okay. So what these two guys did, they realized there is a problem in the market. People are saying we are doing microservice, but they don't know what exactly defines a microservice. This confusion might not click this architecture, but it is a powerful one. So we need to define some standard for the world. And then these two guys in 2014 has defined these standards. These are 9 principles. And once these principles came into picture. Now people had clarity what exactly is microservice. So what these guys did is, okay, what these guys did, just you can read this. On their websites itself, they have mentioned all this information. I just took a screenshot of that. Okay, late 2013s, hearing all the discussions about microservice, this Martin Fowler is saying, I became concerned that there was no clear definition of microservice. The same problem with SOA. So I got together with my colleague James Lewis, who was one of the most experienced practitioner in this style, and together they wrote an article, the firm definition of microservice style, okay, which we did by listing the common characteristics of microservice architecture that they saw in the field. And guys, these are the principles. So when you are discussing microservice in the project or during interview time, you need to use these terminologies, these concepts, and accordingly explain during interview that we are building a microservice based architecture. Okay, take a minute to quickly read through this, or if possible, open up your notepad and just write down these 9 things. Don't take a screenshot, do some hard work from your side, write it down, understand it word by word. Okay, whatever the principles are. Guys, everyone, please open up a notepad and write down these things just quickly, maybe just in your notepad, or if you have a pen paper, whatever works out. Something which I realized about pen paper, I started my career at that time, I used to make a lot of handwritten notes, but over a period of time, these all notes just, it's not possible. You cannot search in notes. Control F does not work in notes, right? So pages gets lost, it's all scattered. So basically having a software Word document will be more handy and it will live with you for a long time. Okay, but anyways, it's your choice. Write down these 9 principles. Today we are going to understand these principles, understand the technicalities behind it. A lot of architectural concepts are there behind these principles. We need to understand a majority of them today. Let's say maybe 5 we might be able to finish, and if you are lucky, maybe 6 also, because every principle is pretty in-depth and having a lot of things to talk about. So write it down, guys. All these 9 principles, please write it down quickly. Team, once you're done, please give a quick thumbs up, guys. And guys, enjoy IT. Don't take anything to pressure. It's a very beautiful industry. Apply your mind. You will enjoy IT like anything. So tension nahi lena hai, right? Don't be worried. Try to love IT, love the discussions. Don't do it like your college time preparation we have to do. Nahi yaar, understanding you have to do. It's a beautiful IT world. Smart people are there doing great things. You are also smart. Let's do great things. So light rakho cheezon ko. Okay? Okay, some of the members completed. Guys, quickly mark a poll if you have done with this. And then we will move to the next point. Where is the poll section? Poll section. Okay. Did you write the 9 attributes? Okay. Yes, done. Chalo guys, there will be some poll which will pop up somewhere in your Google Meet. So please mark it up. And the guys who are on YouTube, okay, so it's public today, but you also please take the actions in parallel. Do the actions. Now, so what is the background about microservice? Okay, we need a technical architecture. Whenever you are building a project, you need some technical guidelines, okay, how to do, what to do. Okay, earlier it was monolith. Everything you bundle together. All the code, this, that, you write it as one single big project, do a big deployment and run it. several problems were there with that. We will discuss some of the problems as we are continuing today's topic. Then people said, oh, monolith is not working. It's having a lot of pain points. We want to go ahead with a different approach. Service-oriented architecture came into picture, which solved some of the problems nicely. But still, the world did not fully adopt SOA, and there were still problems with SOA architecture. Then comes the third thing, microservices. People came, okay, we have to further improve. And then they all started saying, we are doing microservice, and it was powerful, but clarity was not there. What exactly is a microservice system? Then these two guys came into picture, James Lewis and Martin Fowler, and then they defined some ground rules, what we can call it as a microservice-based system. And guys, all these things, if you go to martinfowler.com website, they have mentioned this article, which is still available with nice examples and descriptions. When you have some available free time, definitely go through this one. Okay, their background, then these principles, and every principle they have explained it in very in-depth manner. Okay, characteristics about it, componentization via service, what exactly this means. Okay, some things might be technically a bit challenging for entry level, and that is where our today's session comes in picture, which can help you those things more easily and conveniently. Okay, so that is what it is. Let's go through that. But these two links will be available with you. You can also walk through it later on out of your interest. Especially all the working professionals, I would recommend and request you to read this entire blog word by word till the end. Give this link to AI and brainstorm with AI about every of the points and deep dive into each of the topic, because these concepts are very vital and will apply in your day-to-day application development. Okay? So strong understanding will come with this grip on these topics. Fine. Let's discuss the first principle. Componentization via service. Everyone, please put your full 100% attention on here. Don't do anything else. No social media scrolling, no time pass. If you're lying, sleeping, don't do that. Be fully alert here. Okay, full concentration here. Try to log in from your laptops and let's go to the drawing board. Here we will draw our approach to understand componentization via service. Okay, the basic approach of microservice is what? Let's say whenever you want to do any project development, let's say you want to build this, our payment integration system itself. On Friday we spoke, you want to build the payment integration system itself. What you can do, you can write everything as one big piece of code. Okay, all Java classes needed to build PIS system, you will code it one block. Everything together. And that was majorly a monolith architectural style. Okay, you write everything, you code it, you test it, everything fine. And then you deploy this into one of the environment wherever, and you are going to run your system. This is what is majorly a monolith approach of doing things. You write everything together. Now just imagine if you have 10,000 lines of code. 10,000 lines of code. Even if you want to make modification to one line, okay, when you give a Java C and then you are going to prepare a jar file, what do you think is going to happen? All the 10,000 files will be compiled. Imagine the pain if everything is together. You wrote 10,000 lines of code. You wanted to modify one line in one of the file. When you are doing a compilation, all the 10,000 files will be compiled. Try to imagine. It will take more time to create bytecode for all of these files. Then you are trying to prepare a jar file out of it. You can imagine the size of this jar file is also going to be a big one. Okay. So depending upon how much data it carries, the size is going to be big. And now you can imagine if, let's say, in this 10,000 lines of code, your entire maybe 50 feature code is there. You can imagine 50 feature code, everything together as one big project in one big jar. All the 50 features are there. And then this big jar, size is also huge, needs to be deployed in one of the server, maybe AWS EC2 machine. Now you can imagine, in order to run this kind of system, maybe because you're running so many features and big project, you need bigger machine size. You cannot run with maybe 2-core machine. You cannot run it with a 4 GB machine. You need a bigger hardware to operate. Right? Just imagine. Because everything is going together, this process of building application, deploying application, running the application, that itself is so challenging. And this was one of the major problem with monolith approach. Bundle everything together, and when you're doing this, everything is heavy. Now just imagine, here it becomes even more harder. Let's imagine 50 features you have. Everything is together. Now out of 50 feature, let's imagine one feature is very popular, nothing but, let's say, viral. One feature is going pretty viral. Everybody globally want to use only one feature. Okay, one feature is like mass adopted. They don't want your entire application. They want only one feature which you have built, and everybody's like getting a pretty high scale. Now just imagine if you build this kind of a project and you deploy it here. For running your application, entire microservice runs as one big chunk. All 50 things will run together. And it takes more memory and everything. Now just imagine if one of your feature grows, you have to still grow the capacity of the entire system for execution. Whatever, there are concepts of scaling which we will be discussing in future, horizontal scaling, vertical scaling, nothing but the entire project you have to grow. Maybe instead of having a 4 GB, you might need a 64 GB. And for your entire machine, you are modifying it to 64 GB. It was not really required. But because your architecture is broken, you are facing more problems. Scaling is a big challenge. You don't need it, but you have to buy more bigger systems. Scale up, scale down, everything is pretty expensive into these kind of things. So notice, out of all your 50 features, one is popular. If you want that one feature is growing, only that feature related code should be scaled. Remaining not required. Remaining can work maybe in a 16 GB also. But if you build it in a monolith style, this approach is nothing but building it as a monolith style. Code everything together, build together, and the bundle will go there and run as one big chunk. Scaling is a problem, more time to build, more time to deploy, more resources required, and all these issues. Another problem here, just say you have 50 feature, one feature got modified, remaining was all fine. You want that remaining 49 feature to work, and only one had problem. So you want that only one feature should be updated. Let's take a simple example, guys. You go to LinkedIn. Now LinkedIn is having so many features. Posting an image, posting a video, posting a text, login, forget password, connections, viewing the list of connections, sending connection request. While sending the connection request, include a note feature. All these are, let's say, 50 features provided by LinkedIn platform. Now just imagine if you are building it as a monolith application. Let's say while you are, let's say, sending connection request, there it is going to give you an option to include some text. If you want, you can include some personalized text and then send it. Just imagine if there is a problem into this feature. LinkedIn has so many features. There is only problem with one. Now, if LinkedIn is built like a monolith application, you will make one line of change for this, then all the remaining features, which has no relation with this single connection thing, but everything will be built. Everything is going to be redeployed. You can imagine what nonsense we are doing into the system, right? Arey, if there is problem here only, fix only here. Why are you doing everything else? That's not a smart approach. Then you might say, then why IT had this kind of a smart approach? Arey, you have to think, IT did not reach to the current state right from the day one. Just like any other industry, it evolved over a period of time. Earlier, when less number of features were there, less number of people were there online, even building a monolith was the right thing to do, because everything is pretty lightweight, less code, less feature, less users, system was smooth. But over a time, it evolved, and the old original architecture was not then valid for new demands. So don't say, like when you see some technical discussion, don't say that it is wrong. It was right at that time. Now the market changed, the dynamics change. So evolution is required. You cannot do the things which were running 30 years old. Now you have to learn the current way and then survive in the current way. So get your thinking right. Don't say other things are wrong. It was right at that time. You have to change your perspective. It was right at that time, but then the market evolved, the dynamics changed. So evolution is required. So this is going to be a practical problem. If you want to build a payment system, you can still continue with doing everything as one big box, and that is not going to work out based upon the current demands of the world. So let's write down a few notes about it. Point number one, you can code. No need to make some notes, just observe here. Wherever I ask you to summarize here, you can do. Otherwise, if you find something very interesting, there you do. Otherwise, watch the session. You will not miss any topic because everything is recorded also. You can watch it again. Focus on understanding. Focus on understanding. Grow your mental nature. And guys, it is so beautiful. Even a child can understand new things. So don't say, I'm not able to understand. Even a 5th-year-old child, if you guide properly, can catch new things. The brain is capable. Your brain is capable. You can understand. Allow yourself to understand. For that, focus is required and more work is required at your side. So point number one, we are discussing, you can code entire PIS system as part of one big project, going ahead with a monolith kind of approach. That's not going to work in the current times because of the scale that we deal and the usage in the production that we have. So it's not going to work. Several problems. Too much build time. Next, big jar files. Next, restart will take more time. Next, scaling is a problem. Scaling means growing the capacity. When more requests are coming, then you have to serve it. That is scaling. Like you're supporting 1,000 requests, you want to support 10,000 also. So you need to grow your capacity to serve the request. Scaling is a problem. Okay, if you have change in one feature, you have to build and deploy entire application. Okay, code review will be a problem because you're doing everything together only. Accidental mistakes can happen. Dependency is there between features unnecessarily, right? So code review and mistakes can happen. Now just imagine 20 people working on this entire big code, right? Everybody will be confused. Am I supposed to know entire application? How is that practically possible? Then we will say, no, you work only on these files. Confusion is there. Try to imagine. Because entire 10,000 lines of code is in front of you. You are a developer. There is always confusion. So team adaptation to this kind of a structure is also going to be hard. So all these are serious problems. Team adaptation is a challenge. Okay, so these are all very serious problems. So we cannot go ahead with a monolith style of application, but we need to grow into a different style. And that is where we come up with microservices and these principles. The first principle of microservice is blocking this approach itself. The first principle of microservices is componentization via services. What does it mean? There are two parts to this. One part is componentization. Second part is services. And then there is another concept into the IT componentization via libraries. We need to understand both of these things. Then you can fully get the first principle of microservice. Okay, so what is this? Component means part. So what microservice is? Okay, fine, you have to do the entire coding of 10,000 lines. Okay, wonderful. And for running in production, everything has to run. You cannot cut down your functionality. You will build everything. But what componentization as a service principle says? Firstly, it says, okay, break your project in the form of components. Components means parts, pieces. So let's say this is component 1, component 2, component 3. So break your project as components. Component, component, and this is also another component. Component is part of a project. And now you will end up having 3 different projects. That's what. Don't code everything together. Break it into component means you go ahead building them as 3 separate code bases, 3 separate projects. So these are your components. Okay, that's the point number 1. Break it down into components. So what will happen? The benefit of this, if you want to do any changes, let's say team can easily learn only these things. You don't have to worry about what is there in the other part of the system. Easy for the team to adapt. Compiling this is going to be again small, because now you're not compiling 10,000 lines, you're compiling maybe only 3,000 lines. If 3,000 is big, you can break it down into even smaller components and make it 1,000 lines ka code. So that is the simple approach. Don't code everything together as one big project. Break it down into smaller code pieces, because it is easy to manage things which are smaller in size, rather than trying to do something with an elephant, right? Just imagine in your house, you want to manage an elephant. Everything has to be so bulky. Rather, you have a small pet, let's say a pet cat or a pet dog. Smaller efforts will be required, easy to scale. Hiring getting 5 elephants is further more problems inviting. You can get still 5 dogs and still manage, right? So point is, smaller things are easy to manage, easy to maintain, and that's what. Don't maintain a big code base. Step number 1 of this principle says, break it down into components, smaller, easy to manage kind of components. Okay, fine. Now, what's the point number 2? Okay, how do you execute these components? How do you execute these components? So one approach can be simply like this. One approach can be simply using componentization via library concept. Componentization via library concept. What is that componentization via library? Okay, something like this. You have them as multiple different projects, and when you are preparing a jar, you will get now jar 1, jar 2, and so on and so forth, jar 3 and jar 4. For execution, what you can do is, still let's imagine one of the project is your main application. This project is a main application, starting point maybe of your entire system. One approach could be, these jars, you move them here into the class path of this project. Because guys, they go, in the end, all the 10,000 lines of code should run. Question is how it should run. So you can try to break it into components, build them as separate projects. However, for execution, you can take all these jar files, add it to the class path of this, and start one big application. And guys, this kind of an approach is componentization via libraries. That you created the components, but they are as libraries. They cannot run by themselves. They just need to be shared as libraries to another project where they will run. So guys, this concept is componentization via libraries. Take a minute to understand this. You break your project into smaller parts, develop everything separately. However, when it comes to running, they behave like libraries. They don't execute by themselves. These are just jar files, which are libraries. That's the term for these jars. These are libraries. These jars, we will just give it as part of the class path of some other main application where all the code can run together. This concept is componentization via libraries. Guys, in your notepad, please write down one liner about what do you understand componentization via libraries. Write it into your own words. 1 minute timer. Everyone, what is componentization via libraries? Write it down, one liner. The first concept we understood, don't code everything together, break it into components. Yeah, makes sense. But how do you execute it? One approach is componentization via libraries. So we need to know the right terminologies so that we can have some good discussions during meetings when you are there. Quickly, 30 seconds more to go. And you should be able to explain things in your own words, guys. Okay, that means you understood. If you give definitions, means you don't understand. Right? Three Idiots movie, you might have watched it. Machine ka definition kya hai? Jack. Right? Books ka definition kya hai? Jacketed and no jacketed. Right? Indexed, this, that, blah blah blah. Right? So you don't need definitions, you need understanding. Once you're done, please give a quick thumbs up. And in interview, we actually ask, people should understand. If you give definitions, we know, you have not understood. And my approach of interview is pretty simple. Somebody tells me definition, I am like, okay, don't give definition. Can you please explain it into your own words, maybe a diagram and everything? So then we can also know whether you really know what you're saying. Memorize, everybody can do. You don't have to memorize also, right? Internet already has all the information. I'll Google it, I'll get the definition. But you understood, it can only be, okay, can you explain it to someone? That shows the understanding. Okay, some of the members already completed. Everybody, did you finish? Can we move on to the next point? Full focus, guys, full focus. Okay, Abhishek is on full fire. Larika, Siddharth. Okay, nice. Good, guys. Thank you for confirmations. Let's continue further. Okay, Dishan, Dilip, let's continue further, guys. So, microservice does not say do componentization as libraries. So we understood what is componentization via library. But again, try to understand the problem here. You have partially solved the problem. So good, you have written componentization as libraries. What does it say? Build your project into components. But these components cannot run by themselves. They should be as libraries. What is as library? Means you build it, you will get a jar file, which we can call it as a library. These libraries can be put into class path of other project. Because that is where I said in the beginning, JDBC knowledge is required. Because there, what do? Oracle jar, MySQL jar, those are libraries. You put it into your class path. So that is library concept itself happening there. So working with this JDBC will give you some maturity. That is where we said it is a prerequisite for this. Okay. So you can understand jars and all these things easily when we discuss it. Now, that is componentization via libraries. Microservices is saying, hey, do it componentization via service. Okay. Now, what is the problem with via libraries approach? The main problem still remains the same. Fine, you have split the project into 4. Easy to at least read and make the code changes. That is fine. Compilation time is also saved. But execution time is not saving. Just imagine if you have only changes into this 4th one. Remaining 3 are fine. You modify here. What you will do, remaining jars will be as it is. However, this jar is going to be new. Let's say jar 4.v2.jar. Still, when you're restarting this, entire application has to be restarted. So it will still run. One main application means it will still run like one big machine. So it will still need big resources, more CPU, more RAM, more memory. Scaling and all that is still going to be a problem. So you have solved one part. Okay, this part you have solved. Code should not be together. But execution part you have not solved. Still, the final application which is going there is a very bulky application. And that is where componentization via libraries is not how you should build microservices. But then why are we discussing this point? Because you should understand this is not a dead concept. We are using it every single day in our life right now also. The week one which we did, it was componentization via library. What does that mean? If you go to the project, what are all these Maven dependencies? These are all libraries. These are all the code which is done by the Spring Framework related team. They are not executing it at their end, but they gave the code to us. We have it into our big application. So componentization via libraries is a commonly used everyday practice. Just that when you build your application microservice, you should not do it like this. You should do it componentization via service concept. Okay, so that is the reason we have to understand this library. So, okay, we are using them regularly. Okay, you build your project and make it available as a library. And this library you need to put into another project and the main application runs. The problem is still execution is very heavy. Okay, restart, maintenance, big challenges. Okay, microservice says do it componentization via service. Let's understand what this service means. Okay, the main concept still remains the same on the left hand side, which is don't code entire project as one big project. Rather, split it into components. That part is the same. Okay, so you will take the project, you will split it into components. Component 1, component 2, component 3. Okay, further microservice says, run these components as services. Run these components as independent services. Means you don't need to put this code as a jar file somewhere else. You start this application itself. So every component runs by itself. You can simply technically look at it like this. This is your first Spring Boot app. This is your second Spring Boot app. And this is your third Spring Boot app. Nothing but all these are 3 different projects, 3 different Spring Boot applications. And yes, you can run them all using Java --jar, first app.jar, second app.jar, third app.jar. They all will start in 3 separate Tomcat embedded servers. That is what is microservice recommendation. You have to run your components independently. They are all running as service. What does it mean, running as services? Okay, in a Spring Boot architecture, microservice-based architecture world, when you say you're running as service, means it will run as a separate process. So it will have its own process ID. That's what in the week number 1, when we were doing deployment in AWS, we found what is the unique process ID for our application. That is what microservice says, run them as a separate process. This process is occupying its own memory. So you can define how much RAM and other things it should be allocated. So this is what it is. And when you're running it as a web application, it is going to occupy its own port. So that is what means running it as a service. You run it independently so that it will occupy an operating system process, OS process, which will give it a process ID. It will have its own memory. Now you can define, here I want a 2 GB because that is sufficient for our functionality. But this one is bigger. Here I want, let's say, 12 GB. Here 4 GB is fine. Nothing but more flexibility is coming to you, more control is coming to you. Depending upon the need of the code, you can define resources. So what is componentization via services? Componentization via service says, don't develop your entire project as one big project. Rather, break it into smaller components. Components is part of the project. Now, run these components independently as services. What does that mean? Means they should run as a separate OS process, which will give it a process ID. It should have its own memory. It should have its own port. Nothing but code independently, deploy independently, and execute also independently. That is microservice. Code independently, deploy independently, execute independently, even let's say scale independently. That is all microservice. Okay, so when you run them as service, don't develop entire project as one big project. Rather, break it into components. Next, run these components as service. What does that mean? When you run it as service, it will run as a OS process with its own process ID, occupy its own memory, and then, okay, most of the times, if you for a web-based application, it is going to have its own port. That is what first principle of microservice says. What do you achieve with that? You code independently, deploy independently, and then you scale independently, execute independently. Life is going to be like that. So guys, everyone, please take a minute to write down, okay, your understanding about this principle. Whenever you say microservice during interview, sometimes interviewers, if they are juniors, they will also not have clarity about all these principles. Even sometimes 4 years of experience, people will not have that crystal clarity. Why? Because nobody spent time to upgrade them to really know these principles. But they know technically what is microservice, but they might not be able to put it into these right structures. So when you give interview, in the previous batches, this happened. Some people said for entire 30 minutes, they discussed only these principles and how have you applied it in your project. And they said, and in the end result, they were pretty much impressed by my knowledge, and that person got the offer letter as well. So sometimes junior guys will not even know what you're talking. So you have to really explain it and showcase it strongly. Write it into your own words. What is componentization via service principle of microservice? Once you're done, please give a quick thumbs up. Don't try to memorize these things, guys. Try to understand and write it into your own words. Somehow college time, school time has messed up into our brains. We start memorizing things. It's all about understanding things. Words will come automatically if you understand. Interview is all about explaining. It's not about definitions, right? So once you understand, then only you can do. Okay, very good. Some of the members have already confirmed it. Very good. Let's move forward. Okay. Gulab Shah, Bhushan, Dishant, very good. Abhishek, very good. Okay, let's go forward. Now, the same thing is mentioned into this document also. The first principle says, microservices are structured as independent component or services, okay, each responsible for specific business function. Okay, what this point means, that we will be discussing shortly. That is the principle number 2. Okay, we will discuss that point shortly. But this modular approach enables flexibility, scaling, ease of maintenance, and each services can be developed, deployed, scaled independently. Run as much as possible as services. Okay, it will give you modularity, easy to deploy. Basically, whatever we discussed, that is how microservice should be organized. Okay, Very good. Now let's move to the next principle. Now try to imagine, let's say you're you're a director of a movie. Step by step, you want to evolve the movie. So step number one is break the project. All of a sudden question will come. How do you break this project? How do you decide which code should belong here? Which code should belong here? Which code should belong here? Okay, that thing is clarified by the second principle. So what is the second principle? So you say you want to break the project and run independently. First principle is saying this. But then comes the second principle, automatic question. How do you do this? And for that, second principle comes in picture, organized around business capability. Okay, let's put this into a separate tab. Organized around business capability. That is the principle number 2. Okay, what does it mean? Don't try to complicate things. Even though they use some rough terminologies, conceptually it's pretty same. What they are majorly saying is, okay, look at business functionality. Means don't try to organize this code based upon technical things. Look at functional part. Look at the functionality, related functionality, which is tied to each other. Okay, should be clubbed together. So it's not about coding organization. It's about, okay, what that feature represents. Related features, you put them together. Login is different. Posting is different. Don't put them together. They are unrelated code. Inside posting, now you still make a decision. While you are posting, maybe uploading an image and video, do you want to still consider them related, or do you want them to be two separate microservices? Now, we will discuss a lot of things as part of these principles. You will get this clarity. How do you decide how the feature should be? The first principle says, the principle here says, look at the business functionality. Related business functionality should be put together into same component. Related. If the two functionalities are related, you keep them together. Okay, let's try to understand what will happen if you keep unrelated functionality together. If you keep unrelated functionality together. Okay, let's say you have that project and it is having two pieces of code. One is what deals with login. Let's say another one which deals with forget password feature. Forget password. Another one which deals with connection feature. And another one which deals with posting feature. Four features. Now you want to do some grouping of that into separate components. Just imagine if you group unrelated things together. For example, you decide, yes, I will be making a big component. And in this one, I am going to add forget password feature and posting feature. Unrelated things you are putting together. Fine. So you will be having forget password and posting. Okay. Now just imagine this is a separate code. You have built this project, which is having now two unrelated features. You coded them, you build it, and you deployed it into production. So it's running into live prod systems, live systems that we call it. Live people are using it. Now just imagine if there is some problem which comes into the forget password feature. If there is a problem into forget password feature, what you have to do here? You will go back into your code, which is now this service. or now let's officially use the term, because we are building it into microservice, we will start calling it as microservice because we are thinking about applying microservice principles on these services. So this microservice that we are trying to build, you will go to that code and you will modify forget password feature, change here. Still what you have to do, unrelated feature is also, when you do a compilation here, let's say you want to build a jar file. So first Java C will happen for compilation, then the jar file building. Again, unrelated things also is getting compiled. There is no much dependency between forget password and posting, but because of here is a change, you have to do that also. And guys, just imagine, if you run only one service into production, when you are doing a deployment of this into the production system, when the forget password feature was being deployed, even people cannot do posting at that time. They cannot post because the feature is being deployed. So what is happening? If unrelated features are clubbed together into same microservice, the problem is going to be there. Change in one feature will impact other features. And if they are not related, why do you really put them together? That's the common sense understanding here we need to have. If the two features are separate, let's say if forget password is changed, you only deploy forget password. Why are you deploying posting feature? Because other users of the world might like to do more posting, but you are impacting other features because there is a problem in another feature. Why this happened? Because wrong design happened here. Wrong technical decision making happened. How can you put two unrelated functions together? Unrelated features together. Now they have to suffer together. Impact in one will impact another. Impact in another will impact this one. That is where microservice principle number 2 says, hey, when you are splitting the services, build it around business capability. Look at the business functionality. Accordingly, do the grouping. So that related code should be kept together. Why? Because if there is a change here, forget password, maybe login is a more closely related model. So we would like to put this login and forget password into the same microservice. So if something goes wrong here, this login is also related to the same. So we can say, fine, because our login module was impacted, so both the systems went down, which people will be okay to take. But they say, hey, posting got broken because your another system broke. Business will never be okay with that. So you need to look from all this code which is together, which are related functionality, and then club them together into one microservice. Always note that this will be built together, deployed together, restarted together. So if the features are related, they are okay to do that. If they are unrelated, it will cause impact for other feature users. That is the thought process you need to have when considering how do you split this project into components. So guys, what is the thought here? Related functionality should be put together in separate component. Okay, always know that if you put unrelated functionality together, then when you deploy, restart one feature, the other unrelated feature will always be impacted. So which is not okay. Okay, so that is a basic thing. Look at the functionality. If you feel the two functionalities are okay to go down together, fine, you can put them together. So if the two functionalities are related, then you can say, fine, when you are doing deployment, we can do it for both. It is okay. That is the principle number 2, organized around business capability. Nothing but look at the business functionality, not your technical part, but look at the business functionality. And if the features are related to each other, then put them together. If the features are non-related, so what would be a good design here? We can simply split the project into this manner. So we can simply say, this is our entire single project code. Now we will put them into one component, which can have login and forget password related code. and you will create maybe connection and posting, both are completely independent systems. So we need to put connection as a separate microservice, and we need to put posting as a separate microservice, because always know if one thing goes down, it will cost another. So we would like to put them as separate microservice. So now your project code will be 3 different Spring Boot application. Here the code of login and forget password goes, they are related. Here rest of the things go as well. Okay, so guys, write down the first point as part of this principle. Write down the first point. When deciding which code should go to which microservice, okay, ensure related functionalities are put together. If your, okay, if it's unrelated, better to put in separate microservice. Guys, write down these 3 things, please. Simple, right? It's common sense if you really think here. There's nothing too much memorize. It's just simple common sense. Yeah, if this goes down, that will also go down, and they are not related, then why it should go down? Keep it separate. That will be the decisions when you're building microservices. And every project might have different features, so it's always dynamic decision making on the fly. Okay, guys, once you're done, please give a quick thumbs up, then we will continue further. Guys, please note, there are n number of ways of doing something technically. So I am sharing you one perspective after a lot of discussion, this, that. Okay, but there might be other parallel ways of doing the same system. So technically answers might be different, but that is also right. My approach is also right. Third person might have a third approach also. So there is no one universal way of doing something. Everything is ideas, thoughts. So you have to understand there are more than one right answers. Okay, and yes, you might be getting now some doubts. Yeah, how about in this scenario? How about in that scenario? All those thoughts are valid. You need to take it into AI and then brainstorm and come up with your further understanding. In interview, multiple answers will be given right. So there is no one way of doing things. And it's endless because every mind is different, ideas will be different. So you do your own exploration. Use all my discussions as a base reference, further customize it, evolve it, and explore on top of it. Okay? So don't consider whatever I'm saying, this is the end of the world. No, this is your beginning where you can consider this as base, further evolve to your situations. Okay? And do that your own research, because that is where you will understand it even more. Okay, fine. So chalo, let's continue further. Now, and they go during interview, this is one thing. We don't always score people on top of what answers they are giving. The journey is also important. The thought process is also important. Okay, how did you arrive at that answer? Maybe your journey was correct, but you drew a wrong conclusion. Still, we will consider, no, but thought process is right. This guy can really build things. So let's hire. So it's not about just right or wrong answer. It's like your approach and your thought process. So even evolve in that one. Okay, first point is taken care. Organize around business capability. You have to look at the functionality. Now, again, these things are very much abstract, because you might say the entire project is payment itself. So I want to keep everything as one, because if they are all business functionality, so everything is payment itself. And then we can say, yeah, everything you want to put together. So just thinking from this rule is not enough. You need to think that, no, you cannot put everything is payment related, but still you cannot put them together, because you know that it is very painful to put them together. You know that the main code, even though they all represent the same stuff, has to be further broken down. And that is where you look at payment from more closer eyes. Inside payment, what separations you can see. From outer view, everything is like payment itself. But when you look at internally, you will see further differentiation. You will see further systems which can be different. And then you group them together, and then you're doing it like this. Now, you might say, okay, hey, but I feel these two things are also different. So should I create them as two separate microservices? Okay. Different thought process is required now. There are two more concepts which comes in this principle. What is the second concept? Jeff Bezos on Amazon, long time ago, he laid down this second concept called as two pizza team. What is two pizza team? So they say the microservice size, nothing but how much code you can put together, how much code you can put together in one microservice. So it says the microservice size, how much code you can put together in microservice, okay, depends upon, okay, team size, which can eat two pizzas. That is two pizza team concept. So nothing but, if let's say there are two pizzas of, let's say, large, too large, generally maybe around 6 to 8 people can eat two pizzas and they will be like, yeah, done. What microservice guidance is coming? Okay, if 6 to 8 people can manage that microservice, that much code should go in that microservice. Don't put more than that. Nothing but your team should be able to manage. Now you can say login and forget password is related. But let's say in future, more related functionalities are coming into this layer. What is happening over a period of time? This will keep growing and this itself will start becoming a monolith. Microservice says, no, that's crazy. Microservice says, you cannot keep adding all the related functionality into one project itself. It's practically not possible. You need to cut it down to a two pizza team concept. Nothing but a team size which can eat two pizzas, which generally boils down to 6 to 8 people. Okay, these many people should be able to support one microservice. That's it. If your microservice size is growing, that a team size of two pizza team cannot support it, in that case, you have to split this into two separate microservices. And then maybe some piece of code will go into not here, but rather here. Nothing but your team should be able to manage that microservice. That's the point. So it's not about size. Micro does not always mean it should be very small in nature. No. Microservices can be sometimes big, having a lot of code also, because business functionality defines microservice. If many business functionalities are there related, they can still be together. But if it is hard for your team to manage, you have to further split it. So what should be a thought process? First, you need to ask a question. Okay, is this functionality related? So we can add this in this microservice. So we can add this feature or functionality in this microservice. Second question you need to ask, okay, can the okay, after we code this new change in this microservice, will it support two pizza team? Nothing but, will your team be capable to solve or to manage this much of code? If the answer is yes, then you code it together. If the answer is no, then you have to split the microservice into two separate microservices. Guys, please note, now I'm telling you based upon practical observations, if you create many small microservices, you will encounter a nightmare in your life. Because managing so many small microservices is a lot of work. Separate Git repository, separate CI/CD pipelines, more chances of bugs will be there, monitoring alerts and scaling, everything you have to completely do it. So only if you keep splitting your microservices into small, you are adding more pain to your life. You're not solving the problem. So you need to make microservice decently sized. It should not be too small. It should not be too big. How do you decide all that? Based upon these guideline principles. Are the functionalities related? Then you put it together. Okay, is it okay? Can it be managed by a two pizza team? If it can be managed, then the code only goes here. Otherwise, you have to see, okay, these are all related, but I want to further split it into two. I want to make it even more smaller so that teams can manage. Why is this splitting required? What will happen is, if let's say for managing this code together, we need to hire two more developer. Okay, what we will say, let's split the code and let's hire two more developer and put these two developers to directly work here only. Otherwise, 10 developers, everybody doing the same ownership of the full microservice is very hard. So we can say these two people should become expert into this microservice code only. They don't even need to know this other microservice because remaining 6 people are doing there. So easy for management also. Hiring new people, we will know where what people are required, who is the expert into which area, and that kind of ownership is needed in the project. So that should be your thought process whenever you are defining where you write the code. So simple questions. Don't write everything together. Okay, fine. Related functionalities, try to put them together. But if related functionality is bigger in size, you have to further cut it down into multiple. Now you will say again, but how do you split? They are all related. No, you need to look at it from a more closer eyes. Can there be some grouping between this? And try to find some grouping. You cannot end up saying, no, we want to now build a big monolith because they are very tightly tied to each other. Means something is wrong. You're not able to dissect it. That is where you need to use the AI genius, give your requirements and say, I need to further break it, give me some ideas for that. And then you will be getting the ideas and accordingly, you can split it further as well. Guys, this is the point number 2. So guys, please write down the second point in this principle. Please write down. It's not about the size of microservice. Don't make it too small and don't keep it too big. It should be good enough for a 2 pizza team to take care. If the code is getting, if the related functionality code, let's use all the terminology, related functionality code is getting more than 2 pizza team size, then better to split the MS into another MS, which becomes easy to manage. Simple rules, guys, write it down. Write down the second main point as part of this. Once it is done, please give a quick thumbs up. So everybody, once it is done, please give a quick thumbs up. Okay, some of the members have already done. Some of the names I might not be able to pronounce properly, so please spare me. This one important thing I would like to say. Okay, whenever you are referring me in chat or anywhere talking, right? So you can use me directly by the name itself, Tausif. Okay, don't put a sir title because corporate industry does not encourage the sir culture. You should not do. Okay, so even CEOs of the company, you have to use them by name only. Directors, maybe having 60 years of experience, grown-ups, okay, refer people by name. Okay, a lot of things, there are advantages of this, and I think basic simple advantages. If you keep giving sir, so actually sir pe chad jayenge, right? So if you keep telling sir to your manager always, sir, what happens is they are like, okay, they will feel too much privileged. And then what they will do? Okay, they will like to maybe dominate you because you keep them on a higher pedestal. So you should not do that. Corporate culture, everybody is same. Everybody is professional. Whether it is junior, it's by name. Whether it is even whoever, CEO of the company, it's by name. Try to always address people by their name itself. It's very important. Sir culture destroys the work culture. Please remember that. Sir, madam, destroys the work culture. Okay, so you might say, we are doing respect. No, it has to be by name only. That's how you have to address. It will be hard for new pass outs, because during your schools and colleges, we are all taught to go in that manner. But corporate may address people by name respectfully. If you're feeling awkward, you can put a Mr. in front. Okay, Mr. Tosif, or if whoever you're talking to, accordingly, you can put the title. But yeah, don't use sir culture. It will go bad on you, because in your companies, if your managers, you start saying sir, 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 and then due to some reason you stop calling him sir, that person will be like, okay, pehle sir bolta tha, now he is not saying it, and that gets into ego and other kind of problems. So don't create problems for yourself. And you might not like to call him sir anymore, so then it is like you are forced, and then it is more frustration for you. So keep things neutral. IT is professional. Treat everyone professionally. Dekho, you cannot let your ego come into picture, so you have to be polite. No matter how much frustration you might be having, you have to talk professionally. And if you're not happy with the team, leave professionally, work professionally. Don't get your ego and all those things involved. Keep things pretty light there. Okay? Fine. So address me as Tausif itself. Do that experiment on me. No need to call sir or anything. And practice the same when you're in your corporates also. Okay? Fine. Let's continue further. And many companies will even guide you to do that. But still, some juniors still move into a wrong notion, and don't do that to yourself. Okay, you will face problems in a long run with that behavior. Okay, so that's what it is. So don't do that. Try to learn quick. Okay, fine. So chalo, we have done the second point here. There is one more aspect to this principle. So componentization. Okay, organize around business capability, means related features, you put them together. But still it can be of a big size. No, you should not let it still grow that big. You need to further split it as soon as you realize it cannot be managed by a 2 pizza team size. Generally, these many people should be able to do. That's the second point. Third point which you have to understand about this principle is, okay, your team should be able to take care of that business functionality end to end. Please note, sometimes business functionality will include front-end application plus back-end application plus database. Microservice says your team should have a microservice owning team should have the full capability required to deal with all the 3 sections or whatever other sections might be coming. You should not keep running after other microservice guy. Nothing but they go as independent as possible. Your team should be able to take care of your business function as independent as possible. Don't run after multiple teams. Hey, database, now you do this. Hey, you do that. No, everything, all the skill set required to run that business functionality should be together in a microservice managing team. So please be aware of this. The team should be able to take care of the entire business functionality, whatever skill set that might be. So you should not keep running every time you have some new change in the feature. Now you want to talk to cross teams, that will slow down the productivity. So this is another rule microservice says. So whichever business functionalities you guys are managing, try to even know all the aspects of it. Even though you are starting as a backend, database is a responsibility of the backend engineer. Plus, spend some time even doing some front-end related work also if your microservice needs some functionality on front-end side. But be owner of all the 3 areas. You should be able to take care of your business functionality independently. So guys, please write down the third point. A microservice team, a microservice managing team should be able to take care of that business functionality end to end. It should not be like, now we don't know, we have to run after other people to get their help for managing our microservice. No, it doesn't work like that. So because it talks about the business functionality, so business functionality lies on to other layers also. Your team should be capable to do that. That's the principle. Because wherever you have to run after other people, dependency means more time, more follow-up, and everything slows down. And then those people are like, we are busy with other things, we cannot do this right now, further problems will come. Microservice says be self-sufficient. Okay, be self-sufficient. Please write down this. Okay, very good. Some of you guys have already finished it. Okay, Bhushan is done, Rahul is done, Kashish is done, Abhishek is done. Awesome. आगे बढ़ते. Let's move to the principle number 3. So, 2 principles we discussed. Whenever you say microservice, you have to know the background. There are principles, guidelines of how to do technical application development. Okay. So then microservice came into picture. People started following it. Martin Fowler and James Lewis, these 2 people laid down some base principles. And after that, the world really adopted and grew on these principles. What is the principle number 1? It says, don't write the entire project as one big code, break it down into smaller systems, smaller components, and run these components as separate services. Independently, they should be able to run. So a lot of ease of maintenance and everything will come with that. Okay. Second, but how do you break the project? Principle number 2 comes into picture. Look at the business functionality. Related things you put together. Know the impact. If one thing is modified, whatever other thing is there in that microservice, that will be also affected with that. Then decide, should I put it together or should I have it separately? But when you're trying to split it separate, you need to think not too small, not too big. If too small microservice, that is also pain. Big microservice, that is also pain. Reasonable size microservice should be there. Your 2 pizza team should be able to manage it. As it is growing in size, 2 pizza team cannot take care, then split it into further small thing. Okay, that is what is thought process. Plus, your microservice represents a business functionality. So whatever functionality includes front end, back end, DB, all the members of the team should be capable to build that microservice function end to end. Okay, so please be aware of that. That's the principle number 2. Now let's move to the principle number 3. Okay, very interesting principle. Smart endpoints, dump pipes. Okay, principle number 3. Smart endpoints, dump pipes. Let's discuss this principle. Okay, you go here to a diagram. We have decided that there will be code into different microservices. Now, let's ask a simple question to ourselves. You decided that one code should be here, another code should be here. In a componentization via library concept, let's talk about core Java. You have written A, class A. Let's say in this class A, you need a class B. Now you are saying a code separately, right? So earlier, monolith approach said in the same project, class A and the class B should be there. Just core Java knowledge is required to understand this concept. Class A is there and class B is also there in the same project. Now just imagine if class A wants to use class B, what is the approach, guys? Class A wants to use class B. Simply you will do import, right? You will only do an import. Because in the same project it is there, import B, and then you will call whatever B object, OB equal to new B, and then you will be calling whatever method, ob.m. So when monolith mein code calling is very easy, you just import, they are all together. Now we are saying you have to split the code, A goes here, B goes here. Now just imagine, still these 2 functionalities want to talk to each other because it could be there. One microservice wants to talk to another microservice. That kind of dependencies might still exist in the code. They are different functions, but they want to do some actions together. So in that case, you have split one part there, you have split another part there, and they want to call to each other. How they can really call it? So here there is now a method. Again, all these are practical problems. Here there is a method, and you want to call that method now from that microservice. Earlier you were happily calling. So if you go ahead with componentization via library approach, is very simple. Here you will have a jar file. You take this jar, put it here. Still you can import it and you can call it. So library method, there is no issue. If you want to call this M method of class B, library approach is simple. You take the jar, put it here, and then just import it, and you can do the code accordingly. But in componentization via service, you are not supposed to take this and put it with you. Then comes the point. If your microservice 1 wants to call methods of another microservice, MS2, how exactly you are supposed to do that? How exactly you are supposed to do that? And that is where this principle comes in picture. Smart endpoints, dumb pipes. Nothing but pipes are, somehow these two systems should connect to each other. This we call at pipes. So we are saying it should be dumb pipes. What is dumb pipe? Means don't add much intelligence there. Keep it lightweight. Nothing complex should be happening on the pipe layer. And endpoint should be smart. Nothing but whatever logic is there here, you put all the logic here itself. Means all logic and intelligence you put here. The pipe should be dumb. Basically, when two microservices is trying to connect with each other, this principle applies. Smart endpoints, endpoints, nothing but the end system that you are going to call, which is nothing but we will be writing them as APIs, which can be a REST APIs. So that's what it is. You write all your business logic here itself. Don't put any logic here in the middle tier. That is the recommendation because of this principle, smart endpoints, dumb pipes. So please note, when you're writing the code separately, you don't want to import, but you want to call that method. That method is the intelligent logic. Now, microservice guideline is, okay, you will call that method logic, but while doing that, your approach should be all the intelligence should be there only. Don't put anything. The pipe should be dumb. Don't add intelligence here. Why they are talking about this in such a manner? Dumb pipes and smart endpoints. Okay, that is because of pain of service-oriented architecture. In the service-oriented architecture also, they said break the service into microservices. Break your service into services. Service-oriented architecture also says build your entire project as services. But what happened is in SOA architecture, they introduced one more central component which got complex over a period of time, which was called as ESB, Enterprise Service Bus. And over a period of time, this became so complex to manage, and then people started writing logics here. Okay, they had so much of feature flexibility. Now this is additional software where a lot of coding, business logic, and a lot of things started building here itself. In the market, so many companies came which now started offering their own ESB softwares, and where a lot of logic was going here also. Then what happened over a period of time? When this microservice wants to talk to this another service in a SOA architecture, they used to talk via this common layer. Some logic should run here, and then some logic should run here. Over a period of time, this design failed in a very bad manner. People started messing up with the system. There was no clarity where what code is going. Some code is here, some code is there. And then maintaining this now needs a full build and deployment cycle itself. It became very hard to manage with your SOA style of application development. And that is the reason microservice mentioned this kind of principle. Hey, the pipe should be dumb. Don't put any logic here because it becomes very hard to take care over a period of time. All the logic should belong here only. So if you know the background about SOA and ESB, you will be able to better relate on this principle. Fine, two systems want to talk to each other, but the communication should be lightweight. Dumb pipes, intelligence should be all here. Why this is coming? Because SOA has really showed a lot of pain to the world. Okay, so endpoint is nothing but the APIs that you will be writing. Generally, REST API is a standard in the current times. So the APIs are also called as endpoint. There you put the entire logic. The pipe should be dumb. They should be lightweight. No complicated logic comes into this layer. And then relate it with the SOA, ESB, enterprise service bus, became real big problem for the companies. And then they came up with this principle: smart endpoints, dumb pipes. Okay, take 3 minutes to summarize your understanding and write it into your own words. When you explain this principle during interview, write it, what points you will be specifying, or maybe you're discussing it with your friends or anybody. 3 minutes timer starting. 2-3 things we have spoken about. Okay, everyone please start. Smart endpoints, dumb pipes. They went to calling it as dumb pipe because ESB really made it painful for them. IT is fun, building applications is fun, designing is fun. Try to plant these statements in your mind. IT is not painful, IT is not stress, IT is not pressure. No, people might say all that, but no, it's not that. You have to change your perspective towards IT. You're trying to build this career. It is fun. It is a joy to go every single day at work, building great systems, using great tools, discussing with smart people. Efficient processes are there, efficient tools are there. I don't see any other industry that sophisticated as IT industry. You pick any other industry, there is chaos. IT is structured, there are plans, there are goals, there are deadlines, smart people, intelligent people. It's a wonderful way to interact with these people every single day. Change your perspective. Other industries messed up. Okay? People compromising on work, on ethics, and a lot of things. IT is a beautiful industry. Accountability is there, responsibility is there. Okay? There might be cases, global wars are happening, but in the company, people of different cultures working together, different religions working together, they don't quarrel. They're all working towards a common mission. So it's a great environment. You have to respect, you have to value, you have to build great things together. It's a great place to be, right? Whenever these kind of wars were happening, right? This going here, there, people of different countries are part of the same company now. So there were instructions, hey, here we are all one big system. You cannot really fight internally. And that's what defines IT to a beautiful country or to a beautiful industry. Okay. Yes, you might have your own opinions, but when you go to job, go with a smile on your face. This is what I'm trying to tell you. It's not a burden. It's not a pain. First of all, remember this situation even after you're into the industry. For getting the job, how much hard you are working. Once you start working, then people start complaining on social media. There is so much work. There is so much work. Why all this thing? Array, right now you're struggling for a job. After getting, do you change? Somebody said this very big quote. Okay, never complain that you have too much work, because when you don't have, that's where you will actually see the true colors of life. You are experiencing that right now. Passing the college, want to get job. Remember this, because 80% of the people forget this phase and they take life and career for granted. And that's where the downfall will start. Okay. 3 minutes are done. Please summarize. Smart endpoints, dumb pipes. Smart endpoints, dumb pipes. And there is a reason I stand and take these sessions, because when you're standing, the mind works more sharp and more effective compared to sitting, compared to lying down. If you lie down, mind is also half cells are not functioning sharply. But when you stand, that's the reason. 3 hours standing and talking. Why? My brain will work more efficiently. You also make some setup at your side. 3 hours stuck, be in a table chair environment. Maybe you're listening, you're focused, and maybe walk also, you also here and bit. So be focused, do something to keep your energy levels high, because a sharp mind can grasp things, can think in a smarter manner. Change some ambience for yourself. Okay? Chalo guys, are you done with this? Please give a quick thumbs up. 3 minutes are done. Let's move to the next point. Okay, Rahul Tiwari has completed. Girish has done it. Gulab Shah has done. Okay. Multiple members done. Okay, Samiksha, Abhishek, Mahesh. Good. Akash, nice. Mahesh. Chalo, आगे बढ़ते हैं. Okay, good stuff, Dilip. Everybody push yourself. One aim is, my primary, what I think and why I started doing all these programs is, IT needs better people. and I felt that I might just give right direction. Becoming a better person is your choice, but I might just give a right direction to some of the guys, and maybe IT can be a beautiful place for a lot of people. So that's one of the initiatives. So I will keep trying to build a new version of yourself, which is more stronger than who you are right now. But I will give just seeds. I will plant these seeds in your mind, and but you have to nurture it and evolve to a better version of yourself who is more capable to deal with all challenges of life. So that is going to be a constant aim every single day. Okay, so where you evolve, where you push your boundaries, where you are not ready to take no as an answer. You want job, go for it every single day, morning till evening. Get ready to put yourself there. There is no time to cry, complain, blame. Laga do. Because once you get this attitude, then everything becomes possible. You have dreams, wake up and accomplish your dreams. Same way, learning, upgrading, everything has to evolve. You have to evolve for all those things, right? Fine. So we will keep evolving our thought process, mindset, attitude, technicality, and full person evolution. That will be a constant mission of these 2 months as well. Okay? Chalo dekhte hain. And it is going to be interesting because words are powerful. Okay, if you let the words touch you, it's miraculous. And yeah, I think the right words in the right minds, right now you're ready to learn, upgrade. I think once done rightly, you can evolve drastically. Human beings have the potential. Okay, so you have written some principles with regards to this smart endpoints and dumb pipes. All intelligence on the endpoints. Endpoints are nothing but APIs, and the communication path, nothing but the pipes. Don't put any logic. Don't put any logic there. And there is a pain because of SOA kind of an architecture where ESBs became very complicated over a period of time. So we don't want that bulky nature to happen. Okay, fine. Now let's talk about some more technical aspects of this smart endpoints and dumb pipes. And that is nothing but how microservice communicates. MS1 trying to talk to MS2. How does this communication happen? Everybody, let's focus on that. There are basically two communication styles. One is synchronous communication, another one is asynchronous communication. Okay, synchronous communication, another one is asynchronous communication. What is synchronous communication? These are basics, clarity topic. Everybody should have clarity here. There is microservice 1 and there is microservice 2. Synchronous communication says, whenever a request is executing, first the request will execute here. Then you feel, I need to call another service. Fine, you will make a call to that other service. When you are calling the other service, you will wait for response. You will not run the rest of the logic. And then when this guy runs the full logic, whatever it is, gives the response back here, and then you continue executing. This kind of communication model is synchronous communication model. Sync communication model. Okay, so what is synchronous communication model? Whenever one microservice wants to call another microservice, you call that and you wait for response. Okay, and this is also called as a blocking communication. Blocking communication, that's another terminology, because your thread is now blocked till the time you get a response. So sync model is allowing blocking communication. Your thread is blocked till the time you get the response. So flow is happening. You make an external call, you wait for the response. It's a blocking nature. Then that guy executes it, gives the response, then you continue. That is synchronous kind of communication. Okay, so sync communication. You call external service, wait for response, which is nothing but a blocking nature. And once you get response, okay, you resume back. That's sync. Now, How do you achieve this in a Spring framework environment? In order to achieve this kind of a synchronous communication in the Spring framework environment, okay, they have provided one library in the current time called as REST client library, which is part of the Spring Web module. So in the Spring Web module, they have made REST client library, which you can use for synchronous communication. So in the project, we are going to use this library whenever our one microservice will talk to another microservice. Okay? So please remember this. Spring framework, we already have discussed in the week 1. They have a lot of predefined code which is available in GitHub. Depending upon need of your project, you need to put the right projects and modules in as a dependency where they have written some code already. So REST client is one of such code which is written and will be available as part of your Spring Web module itself. Take it and use it. So how do you achieve sync communication? Using Spring Web and particular API, which is a common practice in the current application, is REST client. Earlier, there was some application REST template, but recent encouragement is to go ahead with REST client related library. This is more optimized, more faster, more easy to understand, and much more future enhancements are happening on this library. Okay? So this is the previous version which was used majority wise, but now it's all switching to REST client library. Okay, guys, everyone, write down one-liner, sync communication, and just write down Spring Web REST client. What is sync communication? Write it down, and then write down REST client. Sync communication. You call, you wait, once you get, you resume. And then what technically how you can do it is REST client can help you accomplish that. So we need to be aware when you do coding, communication will happen like this. Okay, fine. Let's move to the next topic. Async communication. Async communication works in 2 different ways. Okay, so there are 2 models in async communication. So let's discuss this. Okay, async model 1, which basically is fire and forget. Okay, and then there is async model 2, which is both are async model of communication. Async model 2, which is okay, make call and process after getting response. So it's not forget. You make a call, then you process after getting results. Okay, what is all this? Let's discuss that one by one. Okay, first the fire and forget model, which says, okay, when one microservice wants to call to another microservice, you do it in a fire and forget manner. Nothing but you don't wait for the response at all. This style of communication is very much adapted in the current times for different use cases. And in order to accomplish this, there is a concept called as what? Message broker. They use a software in between, message broker. Dekho guys, you don't write logic here. Business logic does not come. So don't think now you're trying to build a smart pipe here. No, it is only messages will be maintained here. That's it. You're not writing any application logic here. So that is a message broker. What are the popular message brokers in the current times? Kafka, ActiveMQ, RabbitMQ, Amazon SQS. And there are many message brokers in the market. Using these kind of message brokers, whenever you want that, some method of this should be called, you will only send a message to this place. What is a sending a message? Nothing but something like JSON request, key colon value. We have not discussed JSON so far, but we will discuss it in future. It is a way by which data can be represented. JSON, this is the syntax of that, key value, data representation. This we call it as a message. And that is where the term comes, message broker. Whenever you want this, there is a method in this microservice. M method, okay, let's say a string JSON body. You have built this kind of a method here. You want that this guy should receive the data, so you have to pass the data here, and that data is called as a message. So as a microservice, you want this other guy to run some code. Here also the same example was there. Here some code is there, you want it to run. Sync model says what? You start, you call, then you wait, that guy processes, gives the response, you continue. Synchronous communication. Using REST client, Spring Web, we can accomplish. Asynchronous communication model 1, fire and forget style. What is that? You just, okay, you want that method to be executed. You will create data for that method, which is nothing but the message with whatever data you need. And then you will send the message to the message broker. So you will send message to the message broker, and it is going to come to these kind of systems. Now, the beauty about this model is, even if currently this microservice 2 is down, still your message will be kept here in the message broker. So in the first approach, if the destination microservice is down, you cannot call it, you cannot call that method. In this approach, if the destination microservice is down, then also the messages will be kept here. That is asynchronous model 1, fire and forget style. You have a message broker in between, a software which will hold your messages. You will keep sending as much messages as you want. It will all be kept here, persisted, retained, backed up. Everything is going to be built here. Next, whenever this microservice becomes available, it is going to connect to this message broker and get that message. Get that message, and then it will execute that message. And after execution, no need to really communicate anything back, because the basic nature is fire and forget. There are other things here, acknowledgement, where you confirm to this guy can confirm. So you can build a confirmation route as well, but common practice, we use these systems for fire and forget style of communication. If you want to build a feature, okay, let's say after some period of time, you ran a logic, some email has to be just triggered to you. We will just run the code and say, hey, send an email to this customer and this is the body. Some other microservice will take it up and send it offline to you. We don't really wait whether the email is delivered. If it is not delivered, customer will say, hey, where are the details? And they will say, okay, no problem, we will send it again. And then they will send it again. So some features exist where you don't need to really have response. Take a minute to understand this communication model. Asynchronous mode of communication, approach 1, fire and forget style. There will be a message broker in between which will hold messages. What is a message? Data represented. That guy needs to run some logic. It needs some incoming data. Method will have parameters, right? The parameter data. So you will take this message object, you will create a JSON object, send it to the message broker. Message broker will keep it. Whenever the listener comes, it will give it here, it will execute. That approach, asynchronous approach, you are not waiting for response. So what is async? That can happen anytime. You're not waiting for any responses. Async model of communication. Async model, fire and forget style. Let's write down into few words. Async approach. Async approach 1, fire and forget style. What is that? Okay, you would need a central message broker. Sometimes use cases will need this kind of scenario, then all of these things will be required. So you would need a central message broker. When you want destination guys, destination services to perform some action, but you don't want to wait, you don't want to know the result of action. Point number 1. Second, okay, second, with this approach, even if currently destination is down, okay, still later when destination comes up, it can process the message. So you will get that kind of a power. Okay, so how it happens? Sender will send message in broker. Next, broker keeps it. Okay, and then when listener comes, it gives the message. So this is the approach of asynchronous communication, approach 1. So you can use message broker softwares like Kafka, ActiveMQ, RabbitMQ. Different softwares have different pros and cons. In different scenarios, you can use different ones. Some is easy to set up, easy to use, enough. Some are for complicated use cases, which are must have. So people will do analysis and then they will use SQS. Amazon SQS is also one of the option, and so on and so forth. Okay, guys, please write down async approach number 1, fire and forget style of communication. You don't wait for response. Process can happen asynchronously. That's it. Okay, execution can happen asynchronously, not real time. It can happen later also. Please write down few points about asynchronous approach number 1. The technicalities also we are discussing, how it can be built using these kind of broker systems in between. Next, Spring has given some libraries where you can use the Java classes to send message to here, to receive the message from here. Okay, so it's all there in the framework. Some annotations you can use and you can achieve all of these things. Once you're done, please confirm, then we will move to the next point. So everybody remember these concepts, because people will use these terms very frequently. Endpoint, okay, then synchronous. Let's do it in an async style. So they will just use these terms. So we have to be very clear what they are talking about. Okay, very good. Many members completed. Let's discuss asynchronous model 2. Okay. Good, guys. Asynchronous approach 2 says it is a bit different. Okay, it is also okay, process something asynchronously. Okay, but the approach works a bit different here. What is the approach? This is interesting, guys. Everyone, please focus. You have one microservice. You have one microservice. You have another microservice. Whenever, okay, first, in this asynchronous approach to other microservice should be up and running. In this asynchronous approach 1, even if other microservice is down, it works. But in this case, the destination microservice should be up and running. Please remember, that's how this model is different. It is async, but it is different. How it is different? Okay, first of all, whenever you are executing the request, a point will come, you would realize other guy should do the processing. So you will make a endpoint call, API call to that system. Okay, how this model is different than synchronous model is, you will not immediately wait for the response. You will call that and you will parallelly start executing rest of the logic here. That is why it is asynchronous in nature. You don't really wait for the response. You can run the rest of the logic here. Okay, so how the steps are going? Step number 1. Step number 2. And you will straightforward move into step number 3 without waiting for a response journey. Further, what is going to happen? That's it. You're running your rest of the code. And then this guy takes the request. This guy is running that part of the code. So this is also happening as part of the step number 3 itself. This is also happening as part of step number 3 itself. And when this response comes, response is going to be returned back to the caller. So it is not a fire and forget style of communication. Okay, response is going to be also given back to this guy. That is going to be a step number 4. Response is also going to be given to that guy. And now comes an interesting point. When this response is given, okay, you can double process. Okay, you can write code. What should you do when this response comes back? This is step number 5. So response handling is also there, plus real-time processing capability is also there. This is second model of asynchronous communication. Yes, that is technically possible. This is called as reactive programming. Reactive programming. You call, you continue. When you get the response, then also you can execute it. Different cases, you can move ahead with reactive programming style. If you want to build this kind of a system, then Spring team has given something called as a Spring Web Flask module, which can be used for doing reactive style of a programming. And there are some libraries like Web Client, which they have offered, which can help you building this kind of system. Okay, so it is okay whenever you want to build very high performance system where you are utilizing your threads to the maximum possible extent, this is the model that people will prefer. For very high paced systems where huge number of requests are coming and you need throughput, greatly fast response time, this is the approach that people will be following. Okay, for our regular systems, you can still continue with our rest of the sync related approach. This applies, but yes, for very high performance system, reactive is the way to go, because all the threads are very nicely utilized. They are not waiting, they just run. So this is a non-blocking way of communication, non-blocking style of communication. The threads are not blocked. Every time the thread is doing something, nobody is blocked on any responses. So faster communication, faster throughput will happen with this approach. Okay, and if you go to this Spring related, let's say REST client, Spring has given some documentation. So there it is saying REST client library is for synchronous communication. Web client library is for non-blocking reactive kind of a communication. And just see, REST template was previously used one for synchronous style, but is now deprecated, means no longer used or supported, and in the favor of Spring documentation is suggesting that go ahead using Spring client for making API calls. And now there are some more technicality that these two things are built up using something called as a Fluent API. When we do the coding of REST client, we will understand this Fluent API and other things in detail. And this was built upon older style, which is a template method API style. So just be aware. And this is still there, sometimes being used, but majorly these two are the libraries for getting sync and non-blocking async, where you still get the response. You want to process the response, but in a sync manner and async manner, reactive style. And you will choose the approach number 2 if you want to do a fire and forget style of asynchronous communication. Even if destination is not available, still you can send it later. When they come, they can process it. This is also a good model commonly seen in the industry. Guys, everybody, take a minute to write down about this kind of a reactive based communication. Okay, async model 2, where you call it, it is non-blocking and you still continue response processing. Write down something about this approach number 2 for async communication. These are concepts, and these will be commonly used discussions in every meeting that you go, because in every project they will make all these decisions, where to do what, how to do what, this, that, microservice breaking, this code should go there. So we all should know it. That's where we are discussing it today as part of the foundational discussions. In future, we might use these terms in our day-to-day discussions while we are building applications. So we need to know all these things now itself. Once you're done, please give a quick thumbs up, then we will resume further. Okay, some of the guys have already completed. But first finish this. Rahul is done. Be fast, be involved. And guys, know it. This is another thing which inspired me during my IT journey. Okay, nobody is coming for saving you. Dekho, I did not come to save you. You decided you want to grow. And that is where we just met each other. That's how the journey of life is. Nobody can do anything for you. You have to do things to yourself. That is where you will become successful. Remember this. Many people fail in life because they are waiting that somebody should come and help me. No, you made decision. I wanted to join week 1. I wanted to join week 2. And I will do something to self-improve. And I will use this and get the job. You made commitments. The life just happened because of your decisions. So always remember this. Nobody is coming to save you. Only your decisions and your actions will save you. And if you don't do that, you will be lost in life. These kind of things just changed my way of living the IT industry. Okay, I have to do everything to myself. I cannot complain and blame. No, you cannot complain and blame. You cannot say I'm not getting job. You need to ask a question. What should I do to get the job? And you have to figure out and do it. And if you don't do it, nobody else on the entire planet is doing it for you. Big realizations. These realizations will change your life. Once you can connect with these statements, when you work, you succeed. When you don't work, you will fail. And that's the expected reality. Then your life changes. Samjho. Samjho, simple hai. People are waiting, God knows for what. Waiting does not take you anything. Complaining, blaming does not take you anywhere. Guys, write down. Asynchronous model 2. Make call. And then you have to do response processing also. There is no blocking approach also. It's a reactive way of building systems. Spring Web Flask and Web Client library can be used for this purpose. And guys, once you're done, please confirm. Then we will move to the next point. It is 12:25 right now. Okay. Gulab Shah, Aftab, Mahesh. Okay, good. Many members completed. Aage badhte hain. Let's move forward. So let's write down a few statements about this. Approach number 2, async. I will also write it. Approach 2. It is basically a non-blocking, reactive communication, okay, where destination should be up and running, and once you get response, you still process it. That's the nature, and you can achieve it using Spring Web Flask. It is reactive style, and it is using Web Client library, which is built on top of Fluent API concept, which is applied. Okay, so please be aware, different scenarios, different approach might be needed. Such applications are for very high performant applications. When you need that, then that's the only option to go ahead. Very high performant systems, best utilization of threads will happen here, because everything is non-blocking. Okay, all non-blocking. Nobody's waiting for anything. They run. And we know CPUs are crazy. They can boom, do so many things, right? So when threads are not waiting, CPU is not waiting, dhoom dhadaka ho jata hai system mein, right? Everybody is like just on and on. That is powerful. Okay? So chalo, let's continue to the next point. So with regards to the principle number 3, we need to be aware of all these things. The logic has to be on the endpoints. The pipe should be as lightweight as possible. And multiple modes of communication where lightweight pipes are there, smart endpoints are there, is the rest of the topic of sync way of doing it, async way of doing it, and these 3 main models of communication between microservices. Chalo, very good. Let's move to the next principle. Showcase these things during interview. 80% of the job seekers will not be able to put the things in right perspective, especially entry level. Once you gain experience, then things will start making sense. 2 years, 3 years, your thinking starts developing. but beginners really struggle. So you need to get the right context. Principle number 4, design for failure. Okay, very important and interesting. Design for failure. This is also a very smart way of operating. What happens is, Nico, how do you succeed in your life? One thing is you say, I don't want problems, but that is never going to happen. Another thing is you realize problems will be there and you become capable to solve your problems. Then you will succeed. Because the second one is the truth. Same thing goes for microservices. You cannot say, I don't want technical problems in microservice, because it is impossible. You cannot build a perfect system. It will always fail, and you need to know that. Design for failure talks about that. Know that your microservices will fail, and then already be prepared to solve those kind of problems by coming up with nice technical solutions. So if you can already build something like that, you will be able to overcome failure easily. That is what is design for failure principle. So not like running away from failure. It's like knowing that problems will be there and then coming up with technical solutions already proactively so that you can solve the problem. Simple approach. People are losing jobs. Layoffs are happening in market. Those who are prepared for that situation, they will get job quickly. Those who have never thought about the backup strategy and how to move forward, if this happens, for them, dead end, and life is really going to break down for them. So preparation of failure will make you successful. That is what microservice ka principle is saying from technical perspective. Design for failure. Know that your microservices will fail and come up with an efficient design. How will you like to deal with these failure situations? Because failures are going to come. Now you have to deal with. So guys, that's the point here. Design for failure says, your microservices will fail. Okay. Technically, lot of challenges will come when you are building and executing your software. You need to anticipate the problem and build solutions around it. That is what is designed for failure capability. Okay, now let's look at it from technical perspective. What exactly this failure means and what are these solutions? Multiple solutions are available in this mark. One of a good solution provided by microservice is what? Circuit breaker. Next, timeout and retry handling. Next, observability. Nothing but monitoring, alerting, and building a system. Building a system where you can catch errors easily and fix it. And that is where you will have some kind of systems as part of this initiative where distributed log management will be there. Distributed log management systems like ELK, Elastic Cache, Logstash, Elasticsearch, Logstash, Kibana, or alternate of this, okay, Grafana, Alloy, Loki. This is also a combination being used for microservice-based application. ELK or EFK could be there. Elasticsearch, FluentD, Kibana. Distributed log management. Next, distributed log tracing can be there. All these are technical solutions which exist in the world because they want to build for failure, find failures, fix the failures. They have built these kind of technical systems. In the projects, when you go, you will find such kind of things. Circuit breaker based implementation, because knowing that system can fail, circuit breaker can help you deal with it. Timeout management, retry handling, observability. You need to monitor your systems, how much CPU it's running, how much like memory it's occupying. Alerting, if something goes wrong, let's say as soon as 80% CPU is up, you should get a mobile message, you should get an email, you should get a Slack notification, Teams notification. So wherever you are working, some kind of update should come. Hey, it's running at 80%. Do something about it. Monitoring is what? Maybe something like dashboards. You go there, you see how the health and everything is looking. So you monitor your system. You alert yourself when something is risky. And then you build a system which is easy to debug. And that is where distributed log management comes in picture. For microservice, these are very common things where distributed log tracing is required. Nothing but some concepts like trace ID and span ID for tracking your request when it moves to different applications. We'll understand a few of these things as part of right now this conversation, but please be aware, these are multiple technical solutions which your project needs when you are designing for failure. You need to know that something can go wrong. And accordingly, you need to build technical solutions to deal with that situation. A lot of monitoring can simply be done by using Spring Boot actuator module. Using Spring Boot actuator, you can do a lot of monitoring related stuff. In order to build distributed logging solutions, yes, there are ways of doing it. Distributed logging, yes, there are libraries available even for doing all this. Circuit breaker, yes, there are libraries available. Let's say Resilient 4J. You can use Resilient 4J for doing this circuit breaker handling mechanism, for timeout and retry handling mechanism. Okay, for all these things, there is all this Grafana and stuff monitoring dashboards available. Grafana is a well-versed software available which can be used for observability, can knowing your system and all these kind of stuff. Then all of these things further are also available. So technical solutions are available in the world, but please be aware, whenever you are building a application, you should know that problems will come. And there are technical solutions available in the world which are needed to be applied in project to deal with those problems. Okay, let's discuss one problem. For example, circuit breaker. Break the circuit. It is pretty simple. If we, let's say, go back to the microservice. There is a microservice M1. There is a microservice M2. There's a microservice M1, microservice M2. Let's say to this microservice, there are other microservices also who are calling using whatever REST API based communication. It could be synchronous or it could be reactive style, anything. Now let's say when you call this other microservice, what if this microservice is not performing good? Not good. What does it mean not good? It is performing slow. Here the CPU is running pretty high. CPU is 90%. Now let's imagine in your laptop, if you run 90% CPU, whenever you open a new software, it is going to be slow, everything problem. When your memory is full, you cannot do anything, right? When your IO operations of your laptop is high. So that's what it is. Your system is not performing good. Just imagine when new request comes into the project, it will definitely be running 100% and the system will definitely crash. So please be aware, in the real world, when you're running your microservice, you build a functionality, but when it is executing runtime, so many problems will come. System is not able to take care of that load. It might crash, the machine might just go down, the process might terminate, memory overflow, this exception, that exception. ultimately what is going to happen? All the invokers who were calling that, they are not going to get any responses. Everywhere, let's say when you make a API call, you are waiting for 30 seconds for response, and that guy is not performing. So after 30 seconds, you realize, hey, there is a problem. After 30 seconds. And now you continue further. Everybody is doing like that. Some services might say, I want to wait for 1 minute. Now you need to understand, even with core Java knowledge, you should know every time you run a code, there is going to be some thread which runs it. Even main method, when you're running, it's a thread. Now for your application, there are limited number of threads. You don't get infinite threads. By default, whatever, around 20 threads or so, some default configuration will be there for your Tomcat application. You can change that. But please be aware, there is a thread pool. Maximum number of threads that your application can use for processing. Now imagine 20 requests came in, and all these 20 guys are making parallelly calls using all the threads. And you're calling that guy. Ripple effect is created. This microservice failed. Now all your 20 threads are making this call. They cannot proceed. When the invoker, let's say front-end browser or any other microservice is calling them, now they will not be able to get any response. This microservice might be doing multiple work. This was one of the work, but all the threads are busy here only. 95% of this other work which this guy can do, this microservice is not able to perform also. So what exactly happened here? Failure bubbled into the system. One part of the system was impacted, but all of the rest of the system is also now bad. This is impacted, this is impacted. A point will come, the entire system stops. And that is a nightmare for any project, right? That is what is failure possibility. Know that when you are building a real world application, things will fail. You write for functionality, but it will fail, and it has to fail because we live in a technical limitation world. CPU cannot perform more than 100%. That's it. Blanket statement. You have a 4 GB ka RAM. You cannot do more than 4 GB. Yes, you have to scale and other things, but that machine is gone, right? So please be aware. You stay in a technical limited world. There are solutions to do improvements, but still there will be technical challenges. Now at runtime, it's a global world. Billions of users coming every single day to big global platforms. You can imagine the scale that we are dealing with. What if one microservice goes bad? What if some developers write some kind of infinite while loops and all the threads are just circling there? Gone. All your resources are gone. Bad coding can destroy the system. For every single thing, making too many database calls can slow down your system. N number of technical problems can occur. Your threads can get exhausted. Your DB connections can get exhausted. Your external HTTP connections can get exhausted. Your loops can just go on. Exceptions might just leak resources and your memory starts piling up. That's the practical world which we are heading into. Now you might say, that's what people say, like, oh, AI is doing the coding. But these realities of the world, what if AI messes up all these things and does not take care of always all these things? That is where smart engineers are much more required now than before the times of AI. Maybe yes, less strength will be required, but remaining people who are needed for the industry, they have to be very strong, knowledgeable people so that they can deal with all this. Basic coding can be done, application building can be done, but the under the hood things of controlling all these and building efficient system, that's not a work of the average job. In a recent interview, Sundar Pichai said this, okay, the software development is changing. Earlier in the world, if this was the scope of a software development, this is the bar of software developers. Now, both these things are changing. This is growing up, this is coming down. Means both are changing. Means with less technical knowledge, now people can build the software. Earlier, more was required. Now, just with prompting, people can build the software. So entry bar for application development is more. Plus, AI is complex, AI is challenging, debugging, building systems around that, and still making sure building the right systems. That problem cannot be solved with regular developers with average knowledge. To do that, experts will be required, geniuses will be required. And that is where this bar is also growing. More expert people are needed, and here more pay is going to be happening as well. More experts needed. So please be aware. Yes, the software engineering is changing. With low bar, more people can do it. But at the same time, the complexity is also going to grow. And we need people who can build the right systems, know what is happening, and build proper debugging and applications to deal with the changing times. Okay, we cannot blindly rely on AI, that AI is just going to build the entire application for us with one prompt. We need to know that the right system is built, which we can maintain and enhance and then modify. And yes, we have to use AI for all that because we will work in smarter manner, but we need strong, knowledgeable people to control the systems in a proper manner. So if you become this into the good part, you will have the job for the next entire life of the IT. You don't have to worry. But if you are not knowledgeable, AI can do a better job than you. And that's the truth as well. So please be aware. Okay. Software engineering is going to change. It is going to be a job where with minimal knowledge and hardly any pay or even no knowledge can exist. No salary. You can be that kind of a person with bad salary and bad knowledge, and then you are always struggling and laying off. Or you can be a person with high paying salary and extreme knowledge, and you will always have job, people will need you. That's the bracket of industry that you are heading into in the times of AI. Both are there. The brackets have shifted. You can belong here or you can belong here. It's up to you. Where do you want to? And that is where strong software programming fundamentals are required, system design knowledge is required, AI and tooling knowledge is required, and then building the right system around it. And these people are rare. Grow towards that. It cannot be mastered in one day. It will need 5 years, 10 years, but a direction, upgrading, certifications, building into scale, building into complexity. So don't doubt the future of programming. The future of coding might be scared, but the future of programming and building great systems, the world is digital and great people are needed to run the digital world. So don't be scared. If you are knowledgeable, the world needs you, the careers will be there, new job roles are being created, the world is evolving, career is shifting, but for knowledgeable people. And those who don't have, future is scary for them. Maybe some other alternate streams will be the right option. Because even in recently, I don't know whether you're aware of this or not, TCS and all, some statements came, some official, unofficial. They are saying 50% of our resources, we will be hiring human. Remaining 50%, we will give it to cost, will go to the AI agents. We will be splitting the cost. Company has to, let's say, anyways pay 1 CR. Just an example. They are saying 50 lakhs, we will put it on human beings. And remaining 50 lakh cost, we will be putting it on using AI tools. So companies are already making, TCS is into these kind of discussions. Not sure how officially they rolled it, but yes, some kind of words and discussions were happening. So people are ready to invest on AI and split. But who this 50% human beings will be? Do you think average bad people who don't have knowledge? No. They will be replaced, and they has to be replaced because AI is far better. Look from company perspective. Look from company perspective. Yes, the people who are strongly knowledgeable, they are needed and they will be paid, and there is going to be a huge spike into the salary hikes also on the right people. But at the same time, problem people will also be there. It's your choice. Where do you want to belong? Okay, it's your choice. Don't be scared, be aware, and then grow in the right direction. You can make a great career as well. Okay, so that's what it is. So all these things which you hear in the market, there is truth to that. And there is a big picture to that. If you understand the big picture, you can navigate for the next 20 years also in a very smart manner. And you should always remember this. You should always remember this throughout your life. Jobs don't have future. People do. Remember this throughout your life. Jobs don't have future. People do. The careers which might be there 10 years ago might not exist today. The development practices which are there right now might not be there in 5 years. So jobs don't have future. The career lines, the ways of working might not have a future, but people do. What does that mean? People have to adapt to the changing world. You cannot say, I know only that way, because that way might not exist in future, and then you will become outdated, and then the world does not need you. People having 10 years of experience in industry, if they don't evolve, the world do not need them anymore. They will lose the jobs. So it doesn't matter what you know or you know not. You have to adapt to the changing world. And those who are doing it, yes, they will have a future. You need to know the truth. There is a practicality to all these things which is going on. There is nothing to be scared of, but being aware is required. If you're not good, yes, somebody else is going to take over. And that is going to happen. And it's already happening in the industry. And nobody can predict what will happen in the next 5 years. Things will be dynamic. But point is, we need good people. That's what it is. Good people with right capability is required. Sharing you all this so that you get a perspective of what is required. Guys, are you clear with all these things? Don't be scared, but be good. If you're not good, then problems are there. That is for real as well. Okay? Fine. And guys, everything can be learned if you want. If you want to learn, you can learn. Nahi karna hi nahi hai, to fir nothing is there for you. Okay? You have to. You need to be willing to do that. And another thing, okay, before we move to the next technical point. These are important things which needs to be clear. Okay, don't say, nahi, nahi, IT is hard, I will go to some other career. AI is coming in all career lines. In that career also, if people don't upgrade, they will also lose the job. AI is coming in all career lines. Point is, every career has to upgrade. So whether you choose IT or whether you choose any other stream, everything has to upgrade. Okay, so fine. Some industries will be hit early, some industries may be late, but upgrading is required everywhere. So don't try to run away from things. Face it and upgrade in that direction. Okay? It will come for all industries. It's already happening. People are questioning, doctor se zyada knowledge to AI tool is having, right? People are cracking big problems which human beings were not able to solve in all the fields. Recent, like lawyer industry, like, can a human being remember all the laws, rules, and regulations and best solutions for best case? No, AI can do that. Image and video processing, looking at cells, what means human beings can miss it, AI cannot. All the fields, right? I think again, somebody like all these guys of top guys, they said internet was the biggest breakthrough. Now next, AI is that kind of revolution for the world. The entire world will change because of AI. The way we think, operate, everything will change, right? Sam Altman said, the way water and electricity became a necessity for us, like that AI will become a necessity for us, which you have to pay charges every single month, the way you pay for your electricity. That kind of utility will become nothing but intelligence as a utility. People will become smart by paying to AI services. Those who don't do, they will be left maybe 100 times behind than the rest of the world. So it will become that basic necessity of life. So the world is changing. Stay upgraded, stay forward. Okay, let's move to the next topic. It's already 12:50. We will complete one more point and then move to the next area. We will be closing this design for failure topic clearly, and then the remaining discussions we will be doing into the future sessions as we know more. For example, before we start working with the database, we will covering this decentralized database management. It all deals with database activity. So we will be using Spring Data JPA. So Before that, we will discuss this principle, and the remaining principle we will discuss whenever a relevant topic is coming. But today we will be closing it on design for failure. Okay, we already discussed design for failure. Problems are there, and know that technical world has limitations, and we need to be able to build system which can solve that kind of problem. Circuit breaker is a solution for this problem. What is this problem? One service is bad, not able to do its job properly. Other services are calling that service and adding more load to that service. Just imagine somebody is already running 90%. You keep adding more and more. It will never become free. And definitely it will run 100%, it will crash. What circuit breaker says? As soon as you, and what is the impact of that? All of your threads are also waiting. All your users are also waiting. And you cannot do anything else also. So problem is there for that guy also, problem is there for you also. How does circuit breaker solve this problem? Circuit breaker says, as soon as you realize that other service is not working, you stop calling that service. Maybe from all of your logic, 5% logic is this use case. 5% is this use case. Remaining 95 might be some other use cases, right? Remaining 95% might be some other logic in your system. So as soon as you realize that this guy is not working properly, you stop calling that guy. You stop calling that guy. And you assume that it is already failed, and you do like failure processing at your side. Why? What will happen because of this? Ripple effect is going to stop. Your system will be healthy. And when your customers are calling you, you will be able to serve 95% of the use cases properly. That is the advantage. Ripple effect of failure. Failure in one part of the project will not impact another part of the project. That's circuit breaking. Break the circuit. As soon as you realize the destination is not working properly, break the circuit. As soon as you have broken the circuit, you stop calling. What is breaking the circuit? Don't call it anymore. Assume it is a failure. Because after calling, you are anyways getting a failure only. If it is not good, you encountered failures after 30 seconds, why not decide a failure now only? What happens? Your service becomes more available and it can run all the remaining use cases properly. That is the first advantage. What is the second advantage? Because you are not calling that guy, their CPU might run all the currently active work and might become available back maybe again at 10%, 20%. So after some time, if you call, that service will be also good. This solution is circuit breaking solution. Circuit breaker behavior. If you realize the destination is not working, you stop calling it. You assume a failure and you stop calling it. What is the advantage of this? This guy gets more time to recover. Another thing, because you are not calling, you are assuming failure, your resources are not blocked on anything, you can continue running rest of the logic. So let's understand the circuit breaker problem first. Okay, let's understand circuit breaker need and solution. Okay, when one MS calls another, when one MS calls another, okay, sometimes the destination MS might not work properly. Okay, if the calling MS is waiting on destination response, okay, if the calling MS is waiting on destination response, all the invoker threads might be blocked. Okay, because of that, the invoking MS will also get affected and not able to do the job. Then circuit breaker comes in picture. And another problem is when destination is already at 90% and you give more API call, it will cross 100 and very high chance it will break. Now that is some truth. Circuit breaker solves this problem. Circuit breaker solves this problem. How? Okay, when invoker realizes that destination is not good, invoker assumes failure without even calling destination. So because of this, invoker resources are not affected, and also destination gets more time to recover, and then invoker can run rest 95% of its functionality. Next, what happens? After you wait for some time, give it time to recover, and after some time, maybe you can configure it. After, let's say, 3 minutes, you can again make a call to that service to check whether it is working. If it is working, you continue calling. If it is not working, again you assume failure. So because of that, 95 times you are running your system properly, right? That is what it is. So circuit breaker continues like this. If the after some time, the invoker will check if destination is up and running. If yes, then starts calling again. If no, then again assumes failure. Again, then stops calling and assumes failure. And this happens automatically. We don't have to do any development. Like one time you set it up and it will just keep running. You don't have to be there to check everything. So this simple behavior is circuit breaker behavior. We will be coding it and seeing everything practically while we are applying it on the project. Okay, fine. Let's move forward. What is the another point that we can discuss here? Same thing, timeout and retry. After how much time you should stop it? If there is a failure, do you want to keep retrying? If there is a failure, do you want to keep retrying? How many times you want to keep retrying? So you need to think about that. And you should not write all this code because everything is already coded in some libraries. You can take the libraries, do some configuration, and you can just get the effect. But यहाँ पे भी there is so much more technicality you have to understand. Which kind of request you can retry? So should all failures be retried or special type of failures be retried? Functional failures should not be retried. No response cases should be retried. So there are so many things here. Just think about it. Okay, let's discuss one more point here with regards to retry. So there is this invoker. And then there is the destination guy. First of all, what is timeout? Many people, junior especially, they say timeout means failure. Array, no, timeout is not failure. Timeout is not failure. You have to think from deeper perspective. When your system makes a call to the external call, that guy runs it and then it is responding back. Let's say you make a API call and you got timed out. Timed out means you did not get response. You said that within 30 seconds, I should get a response back and you did not get. That means you timed out. You cannot consider it as a failure. You need to know when you call this guy, this system was processing your request. What if it was ready and it updated all the DB and everything at 29 seconds and it is ready to respond back? But while it was giving, then because of your timeout, you closed this HTTP connection. But in their system, they've ran everything correctly. Just that they were not able to tell you properly. So please note, timeout is never to be considered as a failure in processing. Timeout means I don't know. I don't know what happened. So when you do the retrying, you need to be careful. Blind retries will not be working for you. You need to first check whether the previous request was processed, not processed. And that is where we need to use whenever we do retry, we need to build the system around idempotency, that whenever you're calling it again and again, their system should not have a damage. So we need to accordingly make idempotent request. And that is how we need to build the system. Further, if they processed it and they gave you a proper response, okay, so maybe let's say you are doing a request to them. First name validation has failed. They are telling you, hey, first name has failed. First name validation failed. Do you think you should retry on this? Arey, you retry this even 10,000 times, they will 10,000 times say that first name validation is failing. So every failure should not be retried. Only the failure where you don't know what has happened should be retried. Generally, juniors are confused on all this. They are like, what kind of failure should we retry and all? Know that whenever the destination system has processed it and given you a proper response, it could be success, it could be fail, then you should not retry. But when they were not able to communicate back to you, they timed out. So in such cases, you can retry it. So every failure should not be retried. No response or I don't know cases should be retried. So again, there is so much technicality behind every single thing that we build into the IT industry, but please be aware of these things. We need to do proper handling of timeout and retry mechanism as well. Okay, so timeout and retry handling. So what is that? Okay, when caller calls the destination, okay, you might set up a timeout window that if you don't get response within that time, your HTTP connection will close. So you will not have the response. Okay, it is possible the destination might have already processed your request. So we need to be aware. So identify when to retry, what failures to be considered for retry, only no response cases, okay, where you when you did not get something proper from the service, no response cases should be retried. That is point number one. Only no response cases. Okay, when you get a valid failure from destination, let's say first name incorrect, so such things you should not retry. Never retry. Even if you retry 1,000 times, every time it will tell false only, right? So only no response case needs to be retried. When you have a valid scenario, then you don't retry. Next point is, when retry, always think about double processing. Because when you retry, if they have already processed earlier, 2 times it is happening. And that is where you need to build a system where idempotent requests are happening, is handled properly. Okay, so please be aware of that. So these are all building for failure needs technical knowledge into these aspects of application development. It's not just about building a functional system. It's about be aware what all things can happen and then do things around it. And like this, there are so many of these concepts. And yes, there's so much to even talk about it. Guys, do you think we should spend more 10 minutes to discuss at least something about these points now itself? Please give a quick thumbs up. Do you think we should spend more 10 minutes now? So logically, you will know more concepts. 10 more minutes lete hain. Okay, it's already 1. We will spend 10 more minutes. Very good. Many people are confirming. So aage badhte. 10 more minutes and then we will take the attendance and we will close. Roughly around 3 hours will be there. Sometimes 3.5. But if it is crossing that, we will immediately stop the session at 1:30 sharp deadline. Worst case mein. We will try to wrap it within 3 hours itself most of the times. Okay. Let's go further. Let's understand. So this is circuit breaking. This is timeout and retry. We need technical awareness of all of these things. Otherwise, we will build a wrong system where double processing is happening. When one part of the system breaks, other part starts breaking. Microservices mein, you need to be more responsible with all of these things, because it's not one project, it is many systems talking to each other. A number of things can go wrong. So we need to be on top of this. Without that, microservice projects will not succeed in production systems. Must have, not optional, must have. Okay, let's talk about these other things. We spoke about monitoring at a high level. Spring team has given a module called as Spring Boot Actuator. It is for basically doing health monitoring. Okay, so Spring Boot Actuator is for health monitoring. What is health monitoring? You go to doctor, something is gone wrong. Immediately doctor kya karta hai? He monitors. Put something in your finger, then BP, sugar, and then pulse rate, heartbeat kaise, right? Those are monitoring parameters. So because if there are changes there, they can immediately sense, oh, this might be happening, that might be happening. That is what is monitoring. In the project also, a lot of technical parts are there. We need to do some monitoring of that to check whether things are proper or not. So you can do health monitoring of your microservices using this module. What could be some of the parameters? Okay, how much is CPU running? How much is memory? Next, how many requests are coming per minute, let's say for an application? How many success happening? How much of failure happening? Errors we are getting? What types of errors? Maybe reasons why these errors are occurring. Nothing but exception processing and all those things. You have to see. Next, you need to monitor. When you run it in scale, let's say you build one microservice. You did everything and you have built one microservice with full functional code. Initially, requests are coming into your system. And let's say 1000 requests, 1K request. And your system is able to perform nicely. Let's imagine when this load becomes 2000, your system cannot perform. Maybe you have to scale. You can do something like horizontal scaling, which is what? You create another machine and then redirect the traffic. Some requests will go here, some requests will go there. You put a load balancer before this and then you operate accordingly. Now, when you're scaling, you need to monitor even that. How many instances of microservices are running? What is going on with all the instances? Where, what is happening? Everything needs to be seen. What if one of the microservices is completely hanged on the database? How will you know that? Production mein sab kuch chal raha hai, but how will you know which instance is hanged on DB? Remaining things are fine, but one guy is gone because a thread got into exception scenario which never came in your testing, and for any other microservice, corner case happened at runtime for this one, and then system is hanged. We need to know that, okay, this microservice is not processing any request at this point of time. Since past 1 hour, it is not processing anything. That is monitoring the system, keeping an eye on the system. Okay, what is going on? Without really getting into logs and other things, we need some central monitoring capabilities. So knowing what is going on in your system, and for that Spring Boot Actuator module is there. With very minimal configuration, you do some basic setup and you will know the health of your microservice. And you can have some nice dashboards. Dashboards, what is dashboard? It's a front-end application where you can see all this thing in a graphical manner. For example, when you open a task manager, this is health monitoring happening of my laptop. Okay, right now, how many CPU, or like right now, how many processes are running, how much memory it is occupying, which process is doing what. This is monitoring. Because now you can do some debugging on top of that. Okay, Chrome guy has taken, Edge guy has taken, and even though we have closed the edge here, still behind the screen, edge is still occupying certain memory. Maybe some cleanup did not happen properly. So when there is monitoring, you know what is going on and you can fix it. The way your laptop is being monitored, we need all our production systems to be monitored. What is going on, where it is going on, and it's a must-have. Without monitoring, projects don't get deployed into production. Okay, so that is where Spring Boot Actuator and stuff comes in picture. Okay, for all big projects. If small microservices are there, few microservices are there, sometimes people might take shortcuts, but big systems cannot exist. For all big systems, strong monitoring is needed. And then you can further extend it and make it alerting. What is monitoring? A kind of proactive way of looking, right? So you open the that dashboard. So dashboard is a screen where you will see all the health parameters, and now you are checking, okay, what's happening, what's not happening. Alerting is what? You configure threshold. Okay, if I am getting these many number of errors in past 5 minutes, raise a alert to me. A mobile trigger should happen, mobile message or a phone call or an email, or maybe if you're working in office, you will use Slack or you will use Teams or any kind of a chat for internal communication. There you will get some notification. So alerting is going to tell you, "Arey, something is wrong, something is wrong." You are eating lunch, you got an alert. Now guys, this is simple thing to understand. People hate. They are like, I want to do the job and get everything in IT. But after office, if I'm asked to work, I will not. Customers are using your project 24/7. Your application can break 24/7. What if you are after your office and then your application breaks? Point is, are you not running away from your responsibility? The job which makes you have food in your house, you are saying, I don't want to do that job. You don't understand your job. That's the first thing you need to realize. Yes, I'm not asking you to work late nights. IT has processes. There are support people who will be hired to be 24/7. But don't you think if you have built a project into the real world, amazing technical solution, and that solution is not working, don't you think it is your job to wake up and do something at that time? Responsible people own the responsibility. Average people will throw it away, and that is where they struggle to have job, and that is where they get laid off. Understand that. I'm not asking you to work 24/7. I'm not asking you to compromise on your life. We spoke about work-life success principle. I believe in that strongly. But don't you think it is your responsibility, the application that you build, if that is not functioning properly, you need to do something to fix it? That's success mindset. It's owning the responsibility. And the people who own responsibility, they succeed. That is what is alerting. So fine, if you feel no, after office all this is happening, you come up with a solution for that. How about you discuss with your clients and say, hey, can we put up a support team? We need to hire 2 people who will work 24/7 support for this one. When one guy is on leave, there is another guy replacing, and then hire more people to do that kind of work. And then they will fix it. If they are not able to fix it, then you can have a second level support where you can call this guy and that guy is going to jump in. But guys, you have chosen to be in the IT industry, and these things can happen. You cannot tell to the rest of the world, hey, don't use my application because now I'm having my dinner. You tell that to the world, the customers go to some other application which is always up and running, and then your project will be terminated and nobody will have job. Understand the seriousness. Job is not a child play. There are real world implications when you do something and when you don't do something. Maturity has to evolve. What we are doing, what is the value of the work that we do, and that is where monitoring, alerting is to make systems responsible. It will make technical systems responsible, but who will make people responsible? You need to do that. Come up with solutions. Fine, if there is pain, you want to don't do this, build up a system where you are not supposed to face that kind of pain. Hire support engineers, and they know that they have to work in shifts, and they will do the job like that because that's what is the role demand. There are people looking for support opportunities in real world who are okay to work late nights, who are okay to do in shifts. That can happen, but don't run away from problem. Own it up. That's what I'm trying to request to you guys. Okay. Fine. I come from pretty management background, 15 years into the industry, 40-member team leading. I've seen all variations of excuses and reasons and problems that people have and what they think, what they don't think. I'm trying to mentor you. what things will make you more successful in your life. Okay, that's the principle number 2. Alerting and monitoring. Alerting will, you will get an email if something has gone wrong. Build a system process wise where there might be some support engineers who can act on that immediately. If they are not doing it, second level support will be there who is supposed to act. If they are not doing it, third level support will be there, and where you might as a developer be involved. Don't hate it. It is a side effect of the work that we do. You cannot tell to the world, okay, when I am off, my application is off. We have built this AI and AWS and these systems to have the application running always. So we have to be available always, right? And that might scare some of you, but if you have system built around it, you will not be compromising on all these. And that is where juniors have all these problems. Once you get maturity, you understand what is what in the IT industry. Okay, so you are choosing to come here in IT, so be aware of all that. Fine, second point is discussed. Let's move forward. We are still in this topic one by one. So many technical things are there, but it needs a lot of thought process. Let's move forward. Circuit breaker, alerting, monitoring. Okay, let's speak about distributed log management, or we can say, okay, central log management and distributed log tracing. Let's use the terms like that. What is central log management? Very, very interesting. Okay, so just look about this. In production, you have one microservice. Logs are what? System.out.println kind of statements. Week 1, maybe discussed it. When this microservice runs, it is going to have some log statements. Okay, what is happening? Let's say there is another microservice. When this runs, it is going to have some log statements. This another guy is also going to have some log statements. These are log statements. Now, let's understand a scenario. When more load comes, more traffic is coming in, this machine is going to multiply. It becomes this. One more instance will be there in production running. This instance is also going to have another log file generated, where all those microservice logs will be there. Let's imagine like this, more load is coming in your application and you keep growing. Service 3, service 4, here also service 2, here also service 2, service 3, and accordingly, those many number of log files are being generated. Now, this is a real problem for microservices. Just imagine if something goes wrong into production system and you are supposed to fix it. Which microservice you will go? Think about it. One request came in, load balancer gave it to this one. This guy called this instance. This guy further called maybe this instance. You have so many log files. You want to check this request traveled how and what was the logs. To do the debugging, that much level of control is required. Now you have so many log files in front of you. How are you going to do the debugging? You need a single place. Otherwise, now if there are 10 microservices, you will open 10 files to see where the log was processed. Even if you might open the file, you might miss it because you're like, oh, I need to open another 10 files. So debugging will become mess if you just have it like this. So what is the solution of the IT? Central log management. Central log management is required for microservice-based applications. Central log management. What does that mean? Don't maintain the logs at every individual places. Rather, centralize all that in one common place. All the logs should be moved into one common place. As you are growing in your experience, then people will expect you to do all these also. Junior level, they will not get into all of these things. But as you grow in your experience, you are supposed to even master these side of things. All the logs should be moved in a central place. What could be that solution? A ELK solution or a EFK solution. Elasticsearch, Logstash, Kibana, or Elasticsearch, FluentD, Kibana. Or you can have another solution, Loki, Alloy, and Grafana based solution. Even this kind of software setup is being used in your companies for microservice systems. What are these softwares? Array, it's nothing but wherever the logs are being generated using this central system like Logstash, Fluent D, or Alloy, these kind of softwares will be running onto these machines and they will be moving the logs here. That is what is this software. They will be moving the log to the central place. They will be running at all these places on all the machines. And they will be moving the log to the central place. The central place is which is available, that we can say it is Elasticsearch. Or in this combination, it is Loki. So all the logs from all the system will be moved in a central manner here. So that as a developer, you don't have to go everywhere. You can go here, you can search here, and you will find everything at ease in front of you. Now that is central log management. Now you want to see this. How do you see these things? That is where you need to have this Kibana or a Grafana based dashboard, which is nothing but just a monitoring software. It's a front-end application, a UI application where you can just go log into Kibana or you can log into Grafana and then you can see this information. Now, let me ask you this question. Do you think these things are optional for a big scale microservice-based application? Is this optional? No, it is not. How can you deploy an auto-scaling system where 50 microservice instances are running? They will all have different files. If you don't centralize it, if you don't view it, your project is useless in production. It cannot exist. You need to hire a support team of maybe 50 people to log into all this thing. Manual chaos in the system. So software solutions are mandatory. And as a developer, you need to get a maturity to understand what is the pros and cons of every single solution. So which are must needed and must mastered by the developers. This is central log management based solution. Using these kind of softwares, we can achieve it. And that's what we can mention here. Using ELK, using EFK, using the combination of these three softwares, we can achieve it as well. That concept is central log management. There is another problem. The way you auto scale, you will be descaling also. When traffic is low, you will delete this. So when you delete it, the log file will be gone. Just imagine a customer, you are a bank customer and you call your bank saying, hey, last week I made a transaction, it did not work. The money was debited, but there are problems. It did not happen properly. Tell me what has gone wrong. If the bank says, we don't know what has happened, that's a shutdown of business if such things happen. Yes or no? As a bank, they are responsible to tell us what goes wrong whenever we are done some transaction. Means logs have to be maintained. It needs to be used to tell what has gone wrong. If you descale, the machines are gone. So these are practical solutions designed for failure. Know that things can go wrong and build a system around it which can take care. And central log management is for that. And the final topic for today is distributed log tracing. What is distributed log tracing? Distributed log tracing. Your microservice will go through so many instances. There has to be something which uniquely says about your request. So when you check these logs, they can tell, right? Every file is separate file. What is that one thing which connects everything together? That can be accomplished using distributed tracing. And here we have to use trace ID. At the entry place, a unique ID will be generated and all the logs which will be printed into this microservice. And when you make a call to another microservice, when logs are printed there, same trace ID will go as well. And that is so beautiful, right? Understand the value of all of these things. These are must have things. And as you grow in experience, you need to know that systems cannot survive without this. And these are not something which can be omitted. Everywhere, same trace ID has to flow so that when you do the logging here, you can search based upon that. Okay, so all these principles are technical things which we should know when we deal with design for failure possibility. So the entire 3 hours today, we discussed about these principles. It was majorly conceptual and technical topic today. Each of the topic that we discussed, go to AI, understand it, whatever things are not clear, work there, read more, explore more, ask more questions, get your clarity. But during interview, you should be able to justify these 4 principles. Remaining, we will discuss it later before the technical part is needed for the project. Tomorrow we are going to work with Stripe related setup. So project related discussions will happen, and must have tomorrow's session will be the base session, and that will be required when we are coding in future. So please definitely attend it. Let's take the attendance for today and we will complete the today's session. Practice is key, and guys, enjoy it. Tension kuch nahi lena. Arey, so many things are there. Let's be a curious mind to learn all these things. Okay, many freshers are like, oh, overwhelmed with all this. Sorry, what is this? What is that? No, you should be curious. Okay, wow, what kind of an amazing IT world you are living in. Once you enjoy, na, then it will be like, Arey, well, let's learn this also. Let's learn that also. Your perspective will change. Okay. So, guys, June 26 attendance. I will share it into our WhatsApp group as well. Tomorrow we will be connecting 10 a.m. We will do a lot of communication in our WhatsApp group today, recording and everything. I will keep sharing it. Just give it a few days. You will understand the entire process, how we are operating. Okay, everything will be just available to you. Just give a few days. You will know the full thing, how we are operating. 5555. Here is the link. And guys, everybody on YouTube also, if you are marking attendance, how many people are there on YouTube by the way right now? 17 people. Okay. So in the WhatsApp group, we will be sharing it up. So you can mark your attendance from there. If you are, anyways, all the enrolled members, these attendance apply for you guys going forward. We will share it in our internal link. Okay. So guys, thank you everybody for your time. It's 1:30 today and we will connect tomorrow. Practice, complete today's topic today only. Technically new, lot of things were discussed. Be clear on terminology. Write down 2-3 bullet points about each of the new technical concept and research the concept on internet today. Tomorrow, some practical Stripe related work will happen. Okay? Thank you all. Have a great day. And chalo, let's put every single day best ourselves. Okay? Thank you guys. Take care of yourself. Bye-bye. I will share this link in the group. Okay? Thank you guys. Bye-bye. Stopping it. Okay, guys. Take care of yourself.